In about two. Ask Andy. Andy, when should it land?
Blend in with the background.
Okay. Hello, guys. This is Paul McWhorter from TopTechBoy.com.
Hi, I'm Christine Lindsay
From
El Dorado High School.
El Dorado High School. And who have we got back here?
I'm Logan.
And
I'm Benjamin.
let's see your head, Ben. Scoot down.
There we go.
Okay. You know, guys, we're doing a quick live broadcast here. What we have going is we have just launched Eagle 8, which is the instrument package that these students have put together. And I want to show you something really incredible. What's our altitude right now?
9,514.
Okay. We're at 10,000 feet, and what I can show you guys is that with the Arduino and Raspberry Pi, I'm going to move us out of the way. With the Arduino and Raspberry Pi instrument package, we are streaming live data from this spacecraft. We launched at 8 a.m. this morning, and we have all systems are go. We've been in the air about 10 minutes. In that 10 minutes, we have what's our downrange velocity?
4.29.
Okay, we're downrange velocity about 5 miles an hour. Okay, our altitude is what? 11,000. Okay, so we're getting right at a couple of miles high, and you can see that our antenna system is successfully tracking this thing. So you're watching live data from the launch. You need to get in the camera there. Okay, there you go. So you're half out.
Sorry.
And you guys get a chair back there so you're a little more comfortable. Okay, and everybody else come in and say hello. So we're just really proud of these students because they've done a great job. Did you tell them that we're live streaming? Okay. Did you tell them that we're streaming? Okay. So we are just enjoying some live video from the spacecraft that we've just launched. The other visual that I will show you that okay, we're gonna start over here. Okay. Hello guys, this is Paul McWhorter from TopTechBoy.com.
Hi, I'm Christine Lindsay from El Dorado High School.
And we are here sharing with you our launch of our Eagle 8 spacecraft. We are about 12 minutes into the launch, and if you look at this screen here, you're seeing live video streamed from our instrument package, which is now at an elevation of what? 11,000 feet. We're about 2 miles high. We're moving downrange at a velocity of what? We're at about 18 miles per hour that we're moving, about 2 miles up. If you look at the video, you can see our little town of El Dorado as we are ascending at an ascent rate of 5 meters per second. We are just really excited that we are getting this live video stream from our instrument package. You guys, as you come on, please feel free to start asking some questions. We're going to be trying to keep our eyes on the questions and see if you guys have questions. What we will be looking at right now is we are just looking and watching the live video stream and hoping that we can maintain that live video stream.
It's looking good.
Yeah, it's looking good. What else can we share? We had the Google Earth. Okay.
You can go to his website.
Okay.
I think Austin's calling you.
Yes, sir.
They were asked. This JD is asking where you can find the link to the live stream.
YouTube Paul McWhorter, and it should be right there on my page, live stream. Okay. So we'll hopefully get some people tuning in here. Guys, what's that?
Our package is right over town, man.
I know. Right.
We're at our heading angle is 52 degrees and our elevation is 60.
Yeah. Let's see. Waiting for an update on the rock block. We're dead over town, right? Right over El Dorado.
Our Our last reading from the rock clock was less than a minute ago.
Okay. How's your signal strength looking?
Let me look. 65.
Okay.
Yes, sir. Yes. Are we moving, Jack, or are we staying? Yeah, we can go ahead and move it. Put some on. You want to stop at the next picnic? Stop at the foot.
Yeah. Let me look.
Should we
You guys
overstay?
stay where you are. Okay.
Stay where we are?
Yeah, stay where you are because it's still over El Dorado. It's just like right over the sewer. Let it get out ahead of you a little ways.
Okay.
Okay. Hopefully we've got some people signing in, you guys, as you join the live chat. We're going to be watching the questions and we'll try to answer the questions. Levi, can you try to watch the chat if we get some people coming on? Okay. This is Paul McWhorter from TopTechBoy.com. We've got a few people that are joining us. We've just launched our Eagle 8 spacecraft, and what we are showing you here is a visual of our projected launch path. The projected launch path is in yellow. And Christine, what are we showing in blue here?
That is tracking our actual package and where it's at.
So this is live data, and you can see that it went a little bit further east than what we thought, and now it's turned around as predicted, and we are tracking this thing in real time. How are we doing on the elevation? Looks like we're pretty accurate on where we thought we would be in elevation. Okay, I see that we've got some viewers coming in. This is live data coming from our Eagle 8 launch, and in blue is the actual real-time data streaming in from the spacecraft, and the yellow is our flight prediction, and so we are tracking this thing in real time. There's another thing that we're tracking here, and Christine, maybe you could describe. We only have one data point, but we've got the red right here. What is the red that we're looking at?
The red is keeping track of where our ambulance is.
Okay, and tell us what the ambulance is.
The ambulance is going to follow the package to retrieve it. And it also has a bunch of other programs running that connects to the package.
Yeah, so we're tracking the data from the ambulance, and then the ambulance is sending the data back to the classroom here. And you can see that the ambulance has departed the launch site, and the ambulance is parked in front of the school right now. Let's check back in with our live data. Okay, it looks like, man, we're getting very close to that prediction.
Yeah.
Okay. We're getting very close to the prediction. Okay, yellow is prediction, blue is live data. How is our video? Do we still have live video coming in?
Yes, sir.
Okay, so let's switch. Okay, so what you're looking at here is our instrument package has a Raspberry Pi on it. We have the Raspberry Pi camera. And what we are doing is we're streaming that data from the Raspberry Pi camera that is on the instrument package, and we are streaming that back to the classroom. And so this is a pretty exciting thing to watch right here. The video is streamed from the instrument package, which is on its way to the edge of space, back to the ambulance, and then the ambulance streams it back to the classroom, and then from the classroom we stream it to the world. You can see the little town of El Dorado down below us here. Let's get some data. What is our altitude?
Our altitude is 1,700.
17 what?
17,000.
Our altitude is 17,000 feet.
Our downrange velocity is 9.
We're cruising at 9 miles per hour right now in downrange velocity. And how far downrange are we from the launch site?
1 mile.
Okay, we're 1 mile from the launch site. But that sort of makes sense because we went up and then we went back around. Also, we can give you a live view here of, well, maybe we can. I guess we cannot. I can't move this. We have a live Skype session with the ambulance, but I'm not able to pull that up. Let's see. Okay. How's your signal strength looking, Jack?
Dead right now.
Okay, so we need to get another data point. All right, so that makes sense. Okay, it looks like we've got some people watching. You guys go ahead and start asking us some questions. We're looking at live video from our Eagle 8 Edge of Space program. Okay, and you guys jump in out there that are watching this. Okay, hello, Robert 2468. We see you come in. This is our live coverage of our Eagle 8 launch, and you can see that we are still getting live video. What is our altitude, Andy?
My altitude is 17,000.
Okay, still at 17,000 feet. Okay, still getting live video. And then we can switch over here to Google Earth and continue to track this live. Okay. Looks like we're not quite at the altitude that we had predicted, but we are roughly following our flight plan. So we've got blue is actual, and the kind of yellow-green is the predicted.
Right under it.
Okay. Jack, are you guys still parked in front of the school?
We are.
Okay, so you guys see this red track here. Okay, hi, John Pashos and Robert 2468. Not familiar with this project. Sounds great. Okay, well, we'll tell you about it. We have an instrument package. The instrument package has a Raspberry Pi and an Arduino. It has a pressure sensor. It has a GoPro camera, and it has a live streaming camera. We are streaming data. We're streaming data from the instrument package as it's on its way to space. We're streaming data, okay, and we are streaming live video. And we are tracking the position of the instrument package in blue, okay, instrument package in blue, and then what our flight prediction is in yellow. And so you can see that we are doing pretty good job. We are doing a pretty good job of staying on our predicted track, but we are a little bit low in altitude, so we're not quite achieving the vertical ascent rate that we had anticipated, okay? But everything else is looking pretty good, okay? I see that we're getting some people starting to watch this and stream. This is our Eagle 8 Edge of Space launch, and we would be happy to answer any questions that you guys have about the instrument package. How did you display the stream data onto the map? Okay, so what you're looking at is the live data in blue, and what the question is how did we get this live data? Okay. The instrument package, the Arduino and the Raspberry Pi have a GPS attached to them, okay? Then that GPS is connected to a satellite modem. The GPS data is sent up to our Iridium satellite network and then is sent from the satellites back to the classroom. In the classroom, we catch that data and we create these KMZ files, and the KMZ files are then automatically running on Google Earth. So in real time, as soon as we get a data point, that data point shows up on Google Earth. And so you can see the yellow, the prediction isn't changing, but our actual flight path is changing. The third thing that we are looking at is the position of our chase crew. And the position of our chase crew is in red, and they are still parked outside in front of the school. The reason that they haven't taken off is they want to give the space probe a head start so that they're not right under it. We want to stay about 45 degrees, but I think you guys are going to need to take off here in the next few minutes because it's starting to get on down the road.
Yeah, we're going to let it get about 45 degrees or 50 degrees.
Okay, so sorry, thank you. Levi, scoot in so they can see you. Just wave at him. Come on, there he goes. There he is, okay. Levi's watching the question. So we talked about how we display the stream data. Okay, I've submitted my project on Arduino distance measurements thanks to your channel. Good job, we got somebody watching our channel. How do you make it run automatic? How do I make what run automatic? Emery, okay. Charles, hello, or Charbel saying interesting. NH High Blogger, Do you send up a helium balloon before the launch to get a general wind direction? No, we just go with the National Weather Center that gives us the wind speed as a function of elevation. We don't use a sounding balloon. Go ahead, you say hello to... yeah.
Hello, gaming.
P something or another. From where? Shout out.
Finland.
Okay.
Wow.
Yeah,
Thank you.
We've got somebody watching from Finland. What is this stream all about? This is the launch of our Eagle 8 Edge of Space probe. We're shooting today to get to 110,000 feet. We have an Arduino, a Raspberry Pi, a GPS, a pressure sensor, a temperature sensor. Am I forgetting anything?
Sounds about right.
Okay. And what you're looking at right now is we are streaming live data. Let's get an update. Where are we? Give me our position, our altitude. Say it loud.
22,000.
We're at 22,000 feet in elevation, and how many miles downrange?
30. Oh, downrange would be 4.
Okay, we're 4 miles downrange. We're at 20,000 feet, and what's our downrange velocity?
Where can you still see it?
We're 30 miles an hour heading downrange, okay? That says what this stream is all about. Okay, TG, thank you. Okay, what is inside the package? Inside the package is a Raspberry Pi. Inside the package is an Arduino, a GPS, a pressure sensor, a temperature sensor, and a Pi cam. That Pi cam is taking live video. You guys, can you give me the video back? Chase crew, okay. And this instrument package that's already, 20 something thousand feet high is streaming live data back to us. The reason the live stream video is not higher quality, it's very high quality down to our ambulance, but then from the ambulance back to the classroom is over the cellular network, so it's getting a little pixelated, but it's looking much better as far as if you were with the Chase crew. Okay, what other questions do we have? Oh, she's disappearing. She's
Didn't dress
yeah.
accordingly.
She's we didn't think the green screen blue is showing up as green on the green screen, so she looks like a floating head. Okay, she looks like a floating head. Good point. Okay. How is she invisible? Okay, we know that.
How
all
do you
right.
predict the flight? What the flight path?
Okay, there is some software that allows you to predict. You've got to model your weight very carefully. You have to model everything else very carefully, but then you can do the predictions pretty good. So, can you use meters? We'll divide by 3. Let's say. What's our altitude? Okay, we're 22,000 feet, which would be 7,000 meters. Okay, we're at about 7,000 meters. Okay, is the Eagle 8 tied to a weather balloon? It is tied to a very special, very carefully designed high altitude balloon. Can we measure UVC in that altitude? I do not know the question to that. Okay, and we've got some flat Earth comments coming in, as you would always expect. Okay, yes, we should see the curvature of the Earth before this thing is. The guys in the Chase crew are starting to laugh. You guys on the video stream, can you hear the guys in the Chase crew? Austin, Jack, you guys talk, and let's see if they can hear you.
Hey, should we go ahead and start moving? Our elevation angle is about 35 degrees.
Yeah, let me take a look. Okay, we are
Yeah.
looking. Yeah, you guys get on the road. Take it easy, though. Our downrange velocity is what? Okay, our downrange velocity is about 30 miles an hour. And so what you need to do is take it slow. You don't want to get under it. You want to stay behind it, okay?
And
Let's
we'll
see.
We want to stick about 45 degrees.
Yeah, don't get a higher elevation angle than 45 degrees. Okay, I am watching from Germany. So you guys that are watching, please give me a comment. Are you able to hear Jack and Austin in the ambulance? Can you hear that? Okay, let me know if you can hear that. Okay, this is interesting. Hello from India. Okay, we have a viewer from India. Hello. Very good. Ultraviolet C. I do not think we have a sensor for that. let us know. Okay, Jonathan, hello. Okay, so you guys are saying yes, you can hear. All right, very good. Before this thing gets over, we will try to get the ambulance live. I've got Skype on here. I'm just not able to feed Skype to you just yet. Okay, I'm not able to feed Skype to you just yet. Okay, everybody's saying they can hear. That's good. And so I hope you guys understand what we're looking at. The green and the yellow, and let me bring this on up. Okay, the green and the yellow is our projected flight path, and the blue is our actual flight path. Okay, and you can see that we are matching the projection pretty darn well, and so this is updating live as this flight continues. Okay. And then the other part of the data, so the blue is our Eagle 8 instrument package. The other part of the data is our ambulance, which is in red. And you can see they left the launch site, they came over, and they parked in front of the school. Austin and they have taken off. The ambulance is on the move. The ambulance is on the move. Okay, well, you guys can actually see. Can you guys see Jack? Jack, can you wave at the camera? There he is. Okay. Can you guys see Jack in the ambulance? Okay, he says, yes, we can hear them. Hello from Yorkshire. Hi, John. Do you have experience with Traquino? No, we have built our instrument package completely from scratch. Okay, so we're not using any commercial things. We built our own GPS and our telemetry systems and all of that. Okay, they can see the Skype. I wish we could make this bigger. Okay, let me see if I can. I'll see if I can get you guys a better Skype image here. Okay. Let me get you a better view here. We're continuing to cruise. What's our downrange velocity?
35.
Okay, we're picking up speed. We're at about 35 miles per hour. Man, look at how well we are nailing that prediction now. It looks like we are still not quite getting the vertical ascent rate that we had anticipated, so we're running a little bit below our projection. But as far as where we're going, we are right on track. Let's look at our questions again. Okay, so yes, we can hear them. They can see the Skype. Yes. Hello from Yorkshire. Hello. May I ask how you get the video stream data at such range? That is the issue, is how to do that. Okay, so how we get the video. Let's go back and see if we got the video still. Okay, yeah, there we go. Okay. What are you doing with the news? Chase crew. Video. Chase crew.
Okay.
Video.
Well.
Okay. Give us a second here. Everyone holds their breath. Okay. Okay, boom. Okay, this is the live video from the instrument package that we're getting. Okay. Hello from north of Sweden. Hello. The prediction is made on the HabHub predictor. You just enter a lot of parameters. You can model your flight. They can see Jack. That's good. Hello from the north of Sweden. Hello, Jonathan. Will there be an explanation and tutorial series on this project? We can try to cover some of this. Hello from Orlando, Florida. Ken, shout out. Okay. So the question was how we get the live video from the instrument package that you're seeing here. And the way we do that is, and I'll go back here so we can continue to watch our KML, our KMZ as we're tracking this thing. The way that we get the live video is we have a Raspberry Pi with the Raspberry Pi camera. It's mounted on a servo so we can control the position. Right now, we have it pointed, how, Christine? We have it pointed down. So you're just looking at the earth down below. Okay, you're just looking at the earth down below. Okay. But as the mission goes on, we will be constantly updating this. Okay, so what we do is we go from the Raspberry Pi to a Ethernet radio that we have reprovisioned to the 2.39 gigahertz ham band. Okay, and then with 1 watt we are transmitting that video signal back to our ambulance. The ambulance is continuing to chase the balloon. Okay. Okay. You send commands to the package using there's 2 ways. We've got 2 data links. One data link through our 2.39 gigahertz radios we're doing Ethernet over ham. Okay, Ethernet over ham. Okay, they're working on some antenna tracking issues, okay, as this thing continues. All right, so what we are looking at, what question was I working on? Okay, commands, we can do it through the 2.39 gigahertz high bandwidth link. That's like a 10 megahertz link. Or we can do it through the very low bandwidth Iridium network. So we have a satellite modem connected to the Arduino. We can talk back to the ground or to the package over the Iridium satellite network or over the 2.39 gigahertz radios. Other questions? Okay, cool. Okay, you should look at VHF, UHF systems, okay? Most of the students, Christine, you have your ham license?
I do.
She has her extra license, and so as a freshman in high school, she got her extra license. We're not using our 40-meter stuff today because we just couldn't quite get the whole thing working. So we will continue to try to incorporate ham more and more into our project. Okay, we can see that this package is going very closely to what we predicted. What is our altitude? We are at 29,000 feet. Ladies and gentlemen, 29,000 feet. What is our downrange velocity? Okay, give me units, please.
Yeah, see, we got
Okay, 35 miles an hour. And what is our downrange distance?
better than like 90.
We're 11 miles downrange, okay? And what else do we have? What is the temperature now at that elevation? It's 34 degrees at, again, the altitude. 29,000, okay.
Man asked if you use
Very
rock
good.
block Mark II.
We use a rock block. I am not sure which one we use, okay.
We got our video back if you want to look at it now.
Okay, they're telling us we got the video back. All right. What happened? Did we?
We can't drive and track it. There's a sensor too far off.
Okay, so you got to drive up and then stop. All right. So the way this thing works is we've got a 1 watt radio on the Eagle 8 package. Okay, we've got a 1 watt radio. And we're trying to transmit, this thing's going to be at 110,000 feet and maybe 50 miles downrange. That means on the ground we have to have a very, very high gain antenna. That high gain antenna is on the top of our ambulance. And as they're driving the ambulance down the highway, they know where the ambulance is in real time, they know where the spacecraft is in real time, and then they solve a complicated mathematical equation that constantly points the antenna. It's a very high gain antenna, about a 25 dB antenna. We've got to point it within a few degrees. What they are observing right now is that if they try to track while they are driving, the antenna isn't getting very accurate. But if they stop and let the antenna catch up, the tracking is accurate. And so right now you are looking at live video from Eagle 8 at an altitude of what? Okay, 29,000 feet, and we are still maintaining both live data and we are maintaining live telemetry. How do we get to telemetry? Okay, this is the live telemetry. So let's take a look. Yellow and green is our predicted flight path. Blue is our real-time streaming flight path. Okay, what's the...
Measure trioxygen.
We probably could. Guys, what we're focusing on this time is the infrastructure to get live video back and the infrastructure to track where everything is. When we get this working, we can then add whatever sensors on future flights that we wanted. But basically, we're just trying to get the communication infrastructure where we're getting video and high bandwidth data throughout the flight back to the classroom. Okay, I'm told that the ambulance is parked in order to get a good signal. So you can see that we're tracking the ambulance. It's gone to the edge of town and it stopped.
Could you go ahead and drive like pretty fast?
Okay. They're
under a little more, and then we'll stop and track.
okay, so now they're going to try to catch back up with it. So the ambulance should take off again, and boom, you can see that there they go. Okay.
Servo move, man.
Oh, the servo move. Okay. All right. Oh, man. Live video. What's our altitude? Okay, at 32,000 feet, what happened is our camera switched to horizontal. Okay. And with the camera at horizontal, you're starting to see the edge of the earth now. Okay. You're seeing the edge of the earth. There goes the sun. And there you can sort of see already the sky is getting dark. Okay, can't use that with the directional antenna. Okay. Okay. Okay.
What GPS module do you use?
The what?
What GPS model do you use?
Okay, we're using. The question is which GPS model are we using? We're using the Adafruit. Okay. How do you manage on atmosphere on antenna receiving signal? Okay. Why is there a sudden increase in projected altitude? Okay, let's see. There's a question on altitude. Let's see what we've got. Okay. All right. So, oh, okay. It's not really sudden increase. It's just as you exit. All right. There was a question about this increase. You see, as you go through the jet stream, it's going down range. The vertical ascent rate is constant, but as you are in the jet stream, it is going down range. Okay. As you exit the jet stream, the vertical ascent rate stays the same, but there's no wind, so it's going straight up. Hopefully we got that question answered. Okay. Yeah, I don't like Imperial System either. What GPS we answered that? Yeah, Adafruit GPS. Okay, so you can see that we're continuing to update in real time the position of our package. It's matching very well to our flight prediction. And let's see where our chase crew is. Okay, our chase crew is here in red. You see they are not able to stay right under it, unlike the Eagle 8 Edge of Space probe, which can go cross-country. Our chase crew has to stay on the highway. So they're going to stay on this highway, and they're going to continue to try to... Okay, they're going to try to keep track of it, all right? Okay, what other question? If we look at 4D Earth, okay. More interest in the shape of the Earth. More interest in the shape of the Earth, okay?
Should be, yeah.
Okay, this one. Okay. Oh, wow. And I'm told the video is a lot better that the chase crew is getting because we've got some very poor data connection between the GPS and back here in this area, poor cell coverage, and so they are able in the chase crew to maintain connection with the package, and then we will periodically have the chase crew drop out depending on their data coverage. So I believe right now the chase crew is in communication with Eagle 8, but we are losing the chase crew So the data is coming from Eagle 8 down to the chase crew. The chase crew is not getting it to us right now because they are losing their cell coverage. We can go back, and even if we don't have cell coverage, we can track them because we track the package through the Iridium constellation of satellites. So we are looking at our flight prediction compared to actual, and you can see that we are doing pretty darn good here. Okay. Boom. Yeah. Okay. So somebody watches my videos. Okay. COD, luck. Yeah. Okay. Let's see. John. Yeah. I'm not getting how you get the live KML file. Okay. This is how we get the live KML file. All right. And that's what you're looking at. So the instrument package, which if you look, is on its way to space right now, or the edge of space. It has a GPS. Okay. The GPS is connected to a satellite modem. The satellite modem is sending the data point of where it is back to the classroom. In the classroom, we have a Python program. The Python program is grabbing those data points, and it's building a stacked set of locations. Then that stacked set of locations, the Python program outputs into a KMZ file, and then Google Earth is showing that KMZ file live. Okay, so let me know if you got another question, and I hope that goes. Okay, I hope that makes sense how we're doing the KML file. Okay, yeah, dogs and cats. I think I probably have one of my Raspberry Pi viewers there. No dogs and cats. Dogs yes, cats no. Okay, let's see. Okay, thank you, Emery. Appreciate the words of encouragement. Okay. Let's see, I believe that also you can see that we mapped out the route a little bit earlier. We mapped out the route, okay, and the chase crew is on the red here. We marked out that route. Looks like they're on the move again. And we marked out areas of poor cellular connection. And so there's going to be places along here that we in Mission Control lose connection. We lose connection with the chase crew, but the chase crew should still be in communication with Eagle 8. Okay, and I can kind of tell when it drops out because I can hear the audio dropping out. Okay, so let's see what we got here. Okay, yeah, and I see that we've kind of dropped them now. And so we will be a little bit of time before we hear from the chase crew again. But even though we are not talking to the chase crew, we are still talking to the Eagle 8. And you can see the KMZ file continues to update, and it continues to follow very nicely our prediction. Okay, let's see, what is our altitude? Say it loud. Okay, we're at 38,000 feet. Downrange velocity is what? Okay, we are at 81 miles per hour now, so we are starting to get up in the wind. Okay, we're starting to get up in the wind. Yes. Yes, Austin? Okay, yeah, you can see here the chase crew is approaching an area where we don't have good cell coverage, but things will pick back up as soon as they get near a cell tower again. But our KMZ files are staying live. Okay, let's go back and see if we've got any new questions coming in. Cats and dogs, we talked about that. This is very zesty. Is zesty good?
Yes.
Is it good to be zesty? All right, zesty. Okay. Thanks. Here's an example of Python combined to KMZ. Yes, what we are doing is we are creating a KMZ file from Python. Oh, I believe we have live video back. Let's see if I can get that up.
This one?
Okay, that one? That one.
Yeah.
Maybe you should drive, huh? Okay, looks like we are getting some video back connected here. What you're doing is you're looking now from, what's our altitude? 38,000 feet, and you're able to look back and you can sort of see a little bit of a low resolution image of the Earth, but from 38,000 feet and maintaining the live video, you start seeing at 38,000 feet the sky is starting to darken up. So the sky is starting to darken up at this altitude. Okay, you can see that we have lost, ow, that hurt. That's so sad. We've lost connection with the chase vehicle. Okay, but we do still have connection. We still have connection with the Eagle 8. So we will go back to Eagle 8 and we will wait for connection with the chase crew. Guys, does that make sense that we have different telemetry streams going? Space to chase crew to mission control, and then we have space to mission control. Space is still talking to mission control. Space is talking to chase crew. We've just lost chase crew to mission control, but we will pick it back up shortly. Okay, what makes the sky blue? Rayleigh scattering. Okay, some people say Rayleigh scattering. That's why the sky is blue. Okay, watching from the sheriff's office. Hey, David Doran. Let's give a big shout out to David Doran. Okay, David Doran is our local sheriff here in Schleicher County, and that's the great thing about being in El Dorado. It's very much of a sense of community. Okay, it's a sense of community, and our chase vehicle is an ambulance that was donated by the Schleicher County Sheriff's Department, and it's decked out with everything you could imagine, and so it really just took our space program to the next level. And so we want to give a big shout out to David Doran and tell him that he is doing a great job, and we appreciate him protecting and serving and being such a wonderful member of the community, along with the entire Sheriff's Department. Okay, what makes the sky? What's that?
Would you send a child up in it?
There's a few that I would like to send up. No, that was teasing. That was teasing. No, we are not doing any. We are not doing any manned space program. Any manned space program yet. And we do hope very shortly to have the ambulance back. Okay, hi from South Africa. All right, man, and got a thumbs up from Annie. Would you send a child? No. Sir, are you using a Pi in the Sky kit? No, man, we build things from scratch. We have a Raspberry Pi, and we built all the instrumentation, Python programs, Arduino programs, live streaming, everything we built from scratch. Okay, so we're not doing any of the kits. Okay, what's that? Ashish high altitude balloon? Absolutely. Okay, radiometrics transceiver. No, we are using a 2.39 gigahertz radios. Okay, we're doing ham over Ethernet, or Ethernet over ham. Okay, this video slowly reducing my self-esteem. Why is that? This should be increasing your self-esteem, right?
Yeah.
I'm an engineer, but right now I am an engineer, but right now I want to be one of your students. All right, TG, come on down. Right, come on down. Let's keep going. Okay, point at it. Okay, how does the balloon come down? The higher you go, the bigger it gets, and then you finally get so high, it gets so big, boom, okay, boom, it explodes, and then gravity, okay, helium up, gravity down, very simple, okay.
Explain about the Iridium satellite.
Iridium is a constellation of, I believe, 66 satellites that give you 100% coverage. 100% coverage across the Earth. And that's nice because you don't really know exactly where this thing is going to go. So we love getting 100% coverage, okay? The downside of the Iridium satellite network is that, okay, we've got a call coming in. Hello? 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 All right, can you get video going?
Getting there.
All right. You guys are live. Jaden, wave, Jaden. Say hello to the world. There she is, saying hello to the world. Austin, say hello to the world. Okay.
Oh,
Okay.
we're not.
Are you guys mobile or stationary? You're mobile. Okay. Do you have a connection? Do you have a connection right now? I guess not. No.
Got the answer.
So again, let's go back and let's look at the. Let's see where we are here. Right here. Okay. So you can see that along their path, you can see that where I put these yellow pins was placed that they don't have good cell coverage. And look at that. Right when they get there, they lose cell coverage. And so we probably won't see them until they come back on. But as they start getting... That was a sad noise, wasn't it?
Yeah.
Very sad noise. Who catches it when it comes down? The Earth catches it, okay? From where are you monitoring it? Okay, we are in El Dorado, Texas, and El Dorado High School at the classroom, okay? And then who you saw briefly, Austin and Jaden and that crew, they are running live. They are running down the road in a ambulance, okay? And we can run lights and sirens. Just kidding, David. We don't really turn the lights and sirens on. I was just joking. Really, we don't. Okay. So we have an ambulance and we chase it in that, and then it's got a parachute and lands on the ground. Okay, we got yeah. I'm guessing you're an electrical engineer. You're way cooler than my mechanical engineer. Man, electrical engineering's where it's at, right?
Yes.
That's where the cool kids go. You know, I'll tell you, in this school, it's pretty cool to be an engineering student, isn't it?
Yeah, it really is.
Yeah, this is the cool place.
Yes. Same.
What time do you guys start getting into school in the morning in here?
6:30.
Yeah, about 6:30, the students start coming in. Levi's usually one of the first ones to come in, okay? And then we see Tanner's one of the first ones. You'll meet these guys in a minute. Once we kind of have a little time, I'll let you meet. We've got like a dozen people in here. Okay, what's our altitude? Say it loud.
44,000.
We are at 44,000 feet. What is our downrange velocity?
54 knots.
54 miles an hour. Guys, that chase crew had better start moving because they are getting behind and they got a lousy cell signal and they can't keep up with the most fabulous Eagle 8. They cannot keep up. All right. Okay, what is this?
Saying that at 18 kilometers will stop. GPS will stop functioning.
Wrong, Mr. Self-Explorer. Wrong. Let me explain. Okay. This is what happens, if I understand right. I think we have gone above 18 kilometers. I shouldn't have said wrong so many times, but, do we have video back? Or?
Probably getting closer.
Okay. Let's see. Answer. Hello? Hello? Earth to Jack. Earth to Austin.
Vaguely heard something.
Yeah.
Oh, there they are. Okay. Wave to the world, Jack.
Dang, it's really cool.
Okay.
Right there.
All right. So, do you guys have signal?
Yeah.
Okay, let's see. Okay. How do I?
This one.
You do it. You drive. Drive.
Hey, y'all have to confirm for the
Confirm. Confirm. Confirm.
Eventually.
Boom.
Okay.
All right.
Let's see.
This is data coming from the ambulance. What you're looking at there is there's a lot of data streaming into the ambulance, and they keep their PuTTY windows open and their ping windows open and all of that sort of stuff. But we are trying to get to live video here. Boom. Okay. So you guys are getting some feedback this time on Skype. So let's try to get that. Oh. Okay, you got that. There you go. Boom. All right. Christine knows what she's doing. Okay. So scoot that way a little bit. Maybe we'll meet some of the other students, but stay in the picture. Okay, so we'll be. Okay. stay in the picture.
Okay.
There you go.
There we
Okay.
go.
So, Levi, come over here, man.
I don't know if I'm in or not.
Okay. Get in the picture, man. Come on, man. All the way. All right. Levi, what time do you get to school in the morning?
6:30, 6:45, somewhere in there.
What do you do for those couple of hours before school starts?
It depends, kind of. I've been through Fusion 360. I've been through SketchUp, which are both 3D printing software stuff. I've gone through the Raspberry Pi, and I've worked on my Arduino some.
And you're what, like a senior in high school?
I'm a freshman.
Boom, freshman in high school. Already knows Fusion 360, Raspberry Pi, Arduino, and SketchUp. Good
Yes,
job.
sir.
Let's talk to someone else. Okay. Kelsey.
Okay. I'll just get in this chair.
Okay, scoot over here so you're in the picture. We'll be all cozy here. Okay, got to get all the way in the picture. All right, there you go. Okay, this is Kelsey. Kelsey is in engineering. What have you learned this year in engineering?
I've learned a lot about the Arduino and coding and writing good programs.
That's right, and you have done a very good job, and you've gotten everything done, and congratulations. Good
Thank
job.
you.
Let's see, and who's this back behind me?
My name is Logan Moore.
And Logan is a championship what? Rodeoer?
Yes.
She is a rodeoer, and she looks small and mild-mannered, but if she was mad, she could rope you and hog tie you before you had a chance to even do anything at all. Okay, looks like that on the chase crew, they're trying to check their signal strength. We're just looking at the video, we're looking at the window in the chase crew, and what they were looking at was they were looking at how strong their signal was, their Ethernet signal from the most fabulous Eagle 8. Oh man, we've probably had some questions. Let me go back and try to get some questions answered. Okay, Self-Explorer, this video is slowly reducing my self-esteem. We saw that. How does the balloon come down? Gravity, we talked about that. Sir, I will also launch high-altitude balloon. Very good. Thank you. Hello from India. Very good. Okay. From where are you monitoring it? We talked about that. Let's see. So glad to see this again. Great to see you, Joseph. An altitude 18 kilometers. Okay, we have gotten really high with the Adafruit GPS, and we have not seen it go off. And there's a lot of technicalities in how different GPS modules interpret the rules, right? The government says that if you are high and fast, shut it down because it's probably an ICBM. But a lot of the GPS manufacturers, instead of high and fast, they did high or fast. And so even if you are a high altitude balloon, they see the high and they turn it off. I believe that we have not seen our Adafruit GPS go off. But Mr. Self-Explorer, if you know more about this, please share. Okay. Does it do what you tell it to? Okay, yes, it does. We can send commands up there. Adafruit GPS will work above 18 kilometers. Yes, I believe, TG, that has been our experience. I am new. Can you explain for a minute what is going on? Oh, okay, we got somebody wanting to know what's going on. Let's come back. We have launched our most excellent Eagle 8 high altitude balloon. Okay. And we are tracking it in real time. What is our altitude?
44,900 feet.
We are at 44,000 feet. Okay, we are at 44,000 feet. We are a little concerned that we haven't seen the thing just take off yet. We're at that period that we should have seen a very dramatic upward motion, which we have not seen yet. But if our vertical ascent rate is lower than what we thought, that could explain that. So in blue, sir, what you are looking at is live tracking of our Eagle 8 space probe, which is at 44,000 feet right now. What's the temperature? You got to yell at me.
4 degrees.
It is 4 degrees at 44,000 feet in beautiful West Texas today. What's our downrange velocity? 47 miles per hour. So you see, guys, we have not come out of the jet stream yet, and so we are starting to cruise. What is our pressure in pascals?
Rock clock went back. So that's why. Mr. Recorder.
Yeah.
The rock clock went back in time. We gave us a point from like 10 minutes ago.
Okay. Yeah, so what these guys are saying as we're trying to track this, the Iridium satellite network. The Iridium satellite network is we're sending the data over. So our Arduino and our GPS is going, I'm here, lat long altitude. I'm here, lat long altitude. And then the Iridium network sends that down to us. Sometimes we always send it in order to the Iridium network, but sometimes it skips one, and then sends. Okay. Uh-oh. How do I get, Christine, how do I get it? Christine, help. Okay, reload, man, reload. Oh, boom, live video from what altitude? Still 44,000, and we are getting live video, man. What do we say?
Boom!
Boom! Boom. Okay.
Oh, that was good.
Look at that. You saw the Llano River down there, man. Did you see the Llano River, or what was it? What was the river? Chase Crew, what's the river? Oh my goodness. Am I going to have to look the river up myself?
Probably.
There was a river down there. What? Oh, okay. Okay, let's see. Adafruit GPS, yes, it'll work. I am new. Can you explain? Yeah, Eagle 8 on its way to 110,000 feet. We're tracking it live on Google Earth. We are also live tracking the ambulance. Okay. Okay, so we are also tracking the position of the ambulance, and it is trying to keep, the ambulance is in red, and it is trying to keep up and chase, and then here is the high altitude balloon, Eagle 8, in real time. We're at what altitude? Okay, thank you. I heard you that time. So just keep watching it, and then when it changes, just yell it out. Just interrupt me and yell it out. What's our outdoor temperature? We're at 4 degrees C, and we're at 44,000 feet, and we've got a downrange velocity of 50 miles per hour, and the chase crew is trying to keep it. And the really neat thing that we have with all this is we are streaming live data back from our package, live video back, and you can sort of see the sky is getting dark, okay, as we're beginning to get close to the upper part of the atmosphere. And our ambulance is cruising down the highway trying to keep up with it. Video stream goes from Eagle 8 on its way to space back to the ambulance, from the ambulance back to here. Step on it. Yeah, step on it. Hey, Austin, you've got somebody on YouTube telling you that you should step on it, that you're getting kind of behind.
We're stepping on it.
Okay, stepping on it.
Step on it. I think we lost it again.
Yeah, lights and siren, man. No, we really don't. Just seriously, we never turn the siren on. We never turn the lights on. Okay, let's see. Surprised you didn't provide a controllable pressure.
Valve?
Where was that?
I think you went down a little too far.
Okay. Okay, I'm trying to catch up on the questions. Look at that video, man. You see that river down there? You're getting live video.
Boom!
Boom. All right. There you go.
I was like so fascinated by the video.
Intercontinental ballistic missile, yeah. Surprised you didn't provide a controllable pressure relief valve on your balloon to control descent. No, man, we got a parachute, and when it's time to come down, it is going to come down. Above that is considered an ICBM. No, I think for it to be an ICBM, it needs to be fast and it needs to be high, okay? But I think if you're only fast or you're only high, you're okay. But it is an area, there's a lot of confusion on Self-Explorer. Thank you. 9 a.m., wake up, I'm lazy. Okay, wake up. I think the parachute will be good for descent. Yeah, we're using a parachute, okay? I understand that you don't know everything, but could you also use a Radiometrics HX1 radio module? Man, to get live video, we have got to have high bandwidth, okay? So we've got to be up in the gigahertz, and so that is why we are doing things this way. Okay, 36-inch parachute will give you a good descent rate. Yep, we have a nice parachute. I think it is probably a little bigger than that. Look, Batman is there. I don't understand the Batman. Oh, okay, yeah, he's got the Batman shirt. Okay, understand. It's nice to see that everyone is still enjoying the class and working hard. Yes, sir, Supernova, they're working hard. Keep working, okay? You will need everything that he teaches you. Yes. You hear this? He's telling you to learn. Yes. Man, live video from space.
It looks great.
Live video from space.
Oh, boom!
Boom. All right.
I get so distracted by the video.
They're not learning. Look at that. It's starting to get black.
Yeah.
No update on altitude? Okay. All right. So let's see. Hi to all. Hi, Ashmini Bose, if I got that right. Spot GPS are the world's... Spot? Are you talking about the Spot Gen? Oh, man, the Spot Gen broke our heart, man. What?
Boom!
You're supposed to say...
55,000.
55,000 feet. Okay. Look at... Yeah. Okay. Thank you. Okay. Let's see. Guys, can you still hear us? We've kind of lost... Okay, that camera is working.
Well, the video looks great.
Yeah. Okay. Guys, I'm not sure if you're still getting the live video of us.
We're frozen.
Yeah, we're...
See that.
Okay. Okay, let's... Yeah, we can. We can see you too. Okay, let me try to get back to these questions, guys. I'm getting behind. The Spot Gen GPS broke our heart. We lost an instrument package because of the Spot Gen. So Self-Explorer, if you're talking about Spot Gen, that one broke our heart. Okay, we've got Michael Molnar, thumbs up back to you. Wish my school would do this type of stuff. Well, maybe you need to move down here where we got the good stuff going, okay? Thank you. I will be joining your class. You're a great man, okay? Who is Never P? Okay, don't know who that is, all right? Ms. Dearman, shout out to Ms. Dearman. Okay. Oh, yeah, best of luck, Ms. Dearman. Our prayers are with you today. Good luck. Thank you for tuning in. You have a very fine mustache, sir. Thank you. That way, when I'm thinking, I can go like this. Yes, very good. Okay. Yay, John. Okay, we got that. Oh, wow, cool. Okay, yeah, son. This is so awesome. I am jealous and my school only reads in books. What? Have we ever in this class opened a book once, ever?
No.
What have we never done in this class?
Opened a book.
Have we ever had a worksheet?
No. Sir.
No. You come in and you get out your what?
Arduino.
Boom.
Boom. All right. We get out the Arduino. Oh, look at that. We got the sun.
Looks good.
Look at that. Live video from space. Uh-huh. Well, on our way to space. Look at that. You see how it's getting black?
Oh, right there.
You see, look at that.
That's nice.
Man, live, the blackness of space. What's our temperature, Ben? 5 degrees Fahrenheit. What's our altitude? We're at 55,000 feet. We should get another data point here shortly. Okay. What's the question? No way that is space. Wow. Well, is it no way or is it wow? Look at that. What do you see? Blackness of space. Okay, guys, can you still see me video or is our video frozen? Okay, let's see. Watching from Zimbabwe. Hey, how's it going in Zimbabwe? I was just watching a video last night from Zimbabwe about some organic farming techniques that you guys have some schools on organic farming technique, and I plan on taking those classes. It's very good, very good. Okay, okay, we're frozen.
He says 58,000 feet now.
58,000 feet. Okay. Okay, sound back. You got the sound? All right, got the sound? Okay, back to the live video. What's that? 61,000 feet. 61,000 feet.
Sound is back.
Okay, sound is back. Guys, if you knew how many channels of data we have got running everywhere, what looks like has happened is our video has locked up. Okay, the video has locked up, but the good news is it sounds like the audio is still working. Okay, it sounds like the audio is still. Okay.
Oh, it says we can't hear.
Okay, audio now, yeah, audio now. Okay, I think you got audio now, right? Will you upload the...
Saying no audio.
Okay, they're 30 seconds behind though, right? They're 30 seconds behind. So I think that they should have audio because we see it over here, okay? We see it over here, but these have... Okay.
Yeah, okay.
Yeah, no. Okay. Okay, we are going to start blocking some people here. I hate to do that, but yes.
I was answering some of the questions.
Uh-huh.
They asked if they will approve the balloon one first, and I said no.
No.
Not on the live video, but we will retrieve and have the GoPro.
Yeah.
And they wanted to know if you will upload that.
Yeah, we'll try to do that, okay? We will try to do that.
It says audio's on now.
Yeah. So I think audio is on.
Just the
All right.
pictures.
Yeah, the picture's frozen, so I'm sorry about that, but there's kind of like no fixing that now. The problem is we have got data coming from space to the chase crew, from the chase crew to here, from here to space. It's just like so much data going all over. What it looks like is that we've sort of overloaded our USBs on the computer and it shut the video off. But if I understand right, I believe you guys can hear me and you can see the screen. So we're just frozen, but everything else should be okay. All right, we have lost the chase crew again, okay, and that's because we have these places like you see, like right here where it says lost signal. Well, sure enough, when they get to that dead spot, we lose the signal. Now, I think we're finally starting to come out of the jet stream and start that vertical ascent. Benjamin, what's our altitude?
Altitude is 61,000 feet.
We are at 61,000 feet. 61,000 feet, and what is our temperature?
12 degrees Fahrenheit.
12 degrees Fahrenheit. So it's interesting, we've gotten down to about 4 degrees, and now we have made it back to 12 degrees. So at a higher altitude, it seems to be warming up a little bit. What was that little ding?
No.
Okay, we have so much stuff going on. Oh, okay. So we have lost the signal to the chase crew. The reason we have lost the signal to the chase crew is they're on the cellular network, and as they're cruising down the highway, they end up in some dead spots. Okay, I am sorry. There is so much going on. Let's try to answer some questions. Okay. You are frozen, but the video is still streaming. Yeah, that's good. What are the benefits of this device? Well, it's pretty cool to be able to get live video as we are on our way to the most excellent 110,000 feet. Okay.
New data point, Jim. It's 65,000 feet up.
We are 65,000 feet. We are waiting to regain contact with the chase crew. Okay. So let's see. We got so many windows here, I'll lose track of what we're doing. Okay, now it is worse. Well, I am sorry. Good job. Thank you. Hi from Germany. Hello, my clips new.
If
Okay.
you want to see the recent ones, just go click on the down there.
Okay. Also from Germany. Hello from Germany. That was not a happy noise, was it? Did y'all try to advertise this launch as much as you could, or was this more of just a launch finish of the year? Okay, yeah, we really, man, we had a tough year getting that tracking antenna on the ambulance. Imagine you're trying to drive down the highway at 60 miles an hour, and the high altitude probe is moving at maybe 100 miles an hour, and you're trying to maintain perfect pointing within a degree or two. That, my friend, is a hard problem. And so we just now are getting all that put together, and so we were not going to live stream it. We didn't advertise, but then at the last minute we thought, hey, things are going so well, why don't we live stream? Okay, so we are live streaming. Okay, weather monitoring, yeah, weather is looking good. At the launch site, it was very calm, looks good at the landing zone. You use most excellent a lot. Well, yes, because this is a most excellent program, Mr. Emery Toth. Okay, then we've got, okay, something, can we make this from watching your videos? Well, you can get there, you can get a long way there. The hard thing is the telemetry. The hard thing is getting the live signal back from space. That is the hard part of it, okay? The live video signal. Send free Wi-Fi up to the sky like Elon Musk. Yeah, Elon Musk is a sort of enigmatic figure. We're not sure about exactly what's going on with Elon Musk. Will this video be available for later viewing? I sure hope so. Also, Indian Institute of Astrophysics. Very good. Indian Institute of Astrophysics. Did y'all end up using the same setup that Will worked on to track the package on the GEM? It's very similar, but we've put better non-axis instrumentation on the antenna so we can more accurately know how we are pointing it. Okay, so that's good. And then also we have put it on the ambulance, so we're driving down the highway with it. Wasn't trying to offend you. Nobody offended. We have a pretty good sense of humor, don't you think? Okay, pretty good sense of humor. What if your device comes in a way? Okay, we have filed a notice to airmen with the FAA, and so we are most legal in everything that we are doing. Do you know approximately where it would touch down before launching? Well, we thought we did. Okay, but the ascent rate is a little slower than what we anticipated. Okay, and now look, now it is really starting to go, right? Now it is starting to go. What is our altitude, Benjamin?
Altitude is still 65,000 feet.
Okay, still 65,000 feet. All right. But you see, we predicted it would take off here, go up here, and it's going up slower. So our ascent rate was not what we had completely anticipated. So we had thought we were going to land near the booming metropolis of London, Texas, but I think we're going to go further, man. We are going to go further. This thing is going to keep going because it's going up slower, so that means it's going to go further before it comes down. Let's see if we can trace our intrepid ambulance crew.
It looks like they should have regained signal by now.
Yeah, Logan's pointing out we should have probably regained signal now. Okay, greetings from Greece. Hello, Greece. Yes. Will you make a tutorial about getting the signals back? I don't know if I will do that or not. Will you try and make this video available? I will try to make this video available. Okay. By the way, I'm getting automatization next year, but due to your vids, I already can work with Arduino. Man, go Arduino. That's all you need. Will you make a tutorial about it? Okay, I don't know the data. I mean, man, how to do this high bandwidth Ethernet over ham. I don't know if I can really do a video on that because that is a pretty complicated thing to do. But I will try to do more videos and more, keep you guys updated on things as we're going. So let's scoot back here and see where we are.
Data point, 69,000 feet.
We are at 69,000 feet.
Boom.
Boom. There you go. Okay. I am so disheartened that our video has frozen. And you just see Christine in a sort of pensive look there, and Miss Logan is not smiling.
Focusing.
Miss Logan is not smiling. Okay, Miss Logan was focused. Okay, that's what we'll say. Miss Logan is focused. All right. I am very, very much wanting to get the chase crew back. Okay, I am very much wanting to get the chase crew back. Check the main camera. Yeah, John. What we have is we have got so much data going so many different places. Our video camera has frozen, but man, I'm just trying to keep the live stream alive, and I'm afraid that if I try to reboot the camera, something's not going to go well. So we are just going to keep on with audio here because you do have live, you just don't have, everything's live except for the video is frozen. And I think what we did is we overloaded our USB ports. We've got so much USB stuff going that I think that is probably what happened. Okay, what programming language did you use? A lot of it was Arduino, a lot of it was Python, okay? And those were the two main things that we did, Arduino and Python. What is our altitude, gentlemen?
70?
71,000.
Would you like
go.
Would you like to announce it?
71,000
Do
feet.
you have a little more flair, a little more...
More flair?
Dramatic, a little more
Oh,
pizzazz, a little more
I thought I
dramatic.
had plenty of
Say,
pizzazz.
I have an announcement. We have an announcement.
We have a very serious announcement. We are now at... Wait, is it still 71?
Oh my goodness.
It looked like it changed.
Get somebody that knows what they're doing. Okay.
Okay, we're at 71,000 feet.
Okay.
Boom.
There you go. What's our temperature?
Our temperature is 20 degrees Fahrenheit.
We're at 20 degrees
Positive?
Fahrenheit.
Positive 20.
Positive?
This is unusual. What's our pressure in pascals?
4,302.
We're at 4,000 pascals, man. And if
Wow.
you know anything about physics, that's a very, very low number, right? You start at like 100,000, and we are 4,000, which means we are getting on up above the atmosphere. Why not using sunlight reflect a signal? Sunlight reflect a signal. I'm not sure. Somebody try to call them. Who has Austin's digits? Okay, call them. See what's going on. Okay, yeah, go call them and see. Hey, how come we've lost the ambulance for some time now, and so we need to. The last that we saw of the ambulance, they were getting close to.
Oh, they're... Yeah.
Live data. Why aren't they? Come on, man. Come on. What's going on?
Gotta call everyone on the chase crew before someone answers.
New data point, 72,000 feet.
Oh, here we go.
Go ahead. Make the announcement.
We're at 72,000 feet right now.
Okay, guys, what's going on?
We had bad cell service, so we're going to get right on the edge of the guard, stop and point again.
Okay.
You're at 70,000 feet.
Yeah, so based on our points, if we stop on the edge of the guard, that's going to put us less than 20 miles that range.
Okay.
Hopefully we'll get out there and get good video.
Okay, turn the audio off. There you go. Okay. Okay, so we're seeing some video here. I have an announcement to make. We have regained contact with the chase crew. Regained contact with the chase crew. All right, so that's good. We have the chase crew. We see the last little bit of video that they took from what is our altitude?
72?
72,000 feet.
72,000 feet. We have data. Austin, Austin, okay, are you aware that our ascent rate is not what we thought it was going to be?
I'm aware.
Okay, so the prediction is stretched out that it's going to probably burst. I'm going to predict that it's going to burst over Highway 83.
Okay.
Okay, and so you guys, if you came down Highway 83 until about the curve in the road, so you're a little bit, I think, south of Menard,
Yes, sir.
just a little bit south on a clear spot, that would be a pretty good place to try to see the burst.
That is exactly where we're headed. So
Okay.
we're on the left side of the guard. We're going to head to the south side, find a good place to stop.
Oh man, you know what I wonder?
Okay, Austin. Meeting has right here. Hey, you'll have Team Europe.
What? Yeah. Are you guys going to get video again?
We're going to stop. Whenever we stop, we'll get it all fired up again.
Okay.
Going right through this part right now.
Okay, so they're going through Menard. Let's see if we can see where they are. Okay, yeah. So here we are. What's our altitude?
72,000 feet.
72,000 feet. The chase crew is in Menard. Okay, so you can see the chase crew. We're tracking the chase crew in red. Okay, they're in Menard, and they're going to come south of Menard and park right about here. I hope you can see my cursor. Right about here. And then what they are going to do is they are going to see if they can regain the signal. They're going to see if they can regain the high bandwidth signal to the Eagle 8 probe, now at 72,000 feet. Okay, and we got the team viewer going. So let's see, we need to somehow... Hello?
Hello?
Yeah.
Okay.
Did we check pylons or anything here? We did everything this way. So should I get out and look? Sure.
And we've got so many windows open here, we can't even keep track of what's going on. Let's see, tools. Oh, come on.
Mr. Chris. All right, got it. Just making sure. With the man.
Okay. All right, so let's go back and see if we can catch up with where they are. All right, so they are now, the chase crew is in Menard, and we can see that they are heading south through Menard. And then we can see that they will be able to park south of Menard, and then they're going to be at about a 45-degree angle to try to point up and recapture that that video signal. So right now they're trying to get to a position where they can recapture the video signal. Okay, so let's say on getting, okay, will you make a tutorial about it? Okay, check the main camera. Yeah, we know that main camera isn't working. I wish I could see outer space, but video keeps teleporting choppy like, yeah. And part of the problem is, remember, we're trying to maintain a live high definition video link from the edge of space back to get the ambulance, the chase crew on the ground, and then we got to get it from the ground back to here. My understanding is they're getting a better video in the ambulance than what they're getting to us, because there's just bandwidth limitations all over and a lot of different things. How much bandwidth are you using for which video? Self-Explorer, which video are you asking about? Okay, we'll give you a second to answer because I know there is a delay.
New point 10, 77,000 feet.
There we go. New altitude at 77,000 feet.
Okay. Okay, we're going to live dangerously, and we're going to unplug the video and plug it back in. Hello, hello. Hey, do you guys hear now? Do you hear?
Yes, we can hear you.
I'm not talking to you.
It's always them.
Sorry. Okay.
It's back. Yay!
Okay, you guys, do you have, you guys in YouTube land, do we have sound and video back? Okay. Do we have sound and video back? Okay, yeah, all right, good. That was kind of scary. All right, so little going. Benjamin, what's our altitude?
Altitude is 79,000 feet.
There we go. 79,000 feet.
All right, 79,000 feet. Sorry I didn't introduce myself. I am a... Oh, okay, so Andy, yeah, okay, very good. Yes, both are working. Okay. YouTube land is fine. Okay, so you guys see what is going on. We are live tracking Eagle 8, okay, our space launch. In the yellow and in the green is our flight prediction, okay, and in the blue is our live data that we're tracking. Also, we are tracking the position of our chase vehicle, the ambulance, and you can see that here. We are tracking. Okay, so we've got the prediction, we've got the live streaming data, and then we've got the position of the chase crew. Okay, so I'm going to try to get the chase crew back. Yes, sir.
How far are we downrange from the package on the last data point?
How far downrange are you? I can give you that. You are 11 miles. Does that answer your question?
Yes, sir, it does.
And man, it looks like it'd be about like a 45, 50 degree angle from where you are now.
Yeah, we have 45 right now, so.
Okay. Are you
Yeah.
getting any pings from the radio?
We are, but it's spotty, so we're going to recalibrate. We're going to twirl real quick on our sender to get a better data set, and we'll see if we can get it.
Okay. So guys out in YouTube land, we are probably up above the jet stream at this point, okay? And we're starting our final ascent leading to the burst, okay? And what we're trying to do is we're trying to regain the video signal. We have a signal from the chase crew back to the classroom, 83,000 feet. Okay, so this thing is continuing its climb, but the chase crew is parked right here outside of Menard, and the chase crew is trying to reestablish contact with the probe on the high bandwidth video. But if I just look at this from the side, the thing I'm concerned about is, let's see what our downrange is. Our downrange distance is about 15 miles, and then it is 84,000 feet, man. We are on the way up. 84,000 feet on the way up. But what I am concerned about is it's starting to look like it's a very steep angle that we are trying to point our antenna. Okay, very steep angle that we are trying to point our antenna. And it is an omnidirectional antenna. I have got just a big mess on here.
Yeah.
Okay, so what's going on? We're trying to point at a very steep angle, and the antenna on Eagle 8 is omnidirectional. That means it wants to shoot out. It wants to shoot out, and I'm afraid we're getting too far below it, so we maybe are not in the sweet spot of the antenna. On the ground, we have high gain antenna,
85,000 feet.
85,000 feet, and climbing. What's our temperature?
Temperature is 41 degrees Fahrenheit.
It's what?
41 degrees Fahrenheit.
Okay, that is probably an error.
Yeah.
So do we need to move?
Okay, you know, guys, this is kind of interesting that our temperature is building up, and you would think that we'd be like 40, 50 degrees below zero, but we're reading like 40 degrees Fahrenheit. And I think what is happening is as you get above the atmosphere, the electronics are not able to cool because you can't get convection because there's no air. And I think probably we are heating things up because of all the electronics. And so probably we have self-heating from the electronics, and that's why we're seeing some rather anomalous signals.
Could a mouse survive at 41 degrees?
Be pretty close. It would be pretty close. Okay. Christine, get in the picture, man.
Hey.
Okay, and here we have Mario. Mario, how are you enjoying engineering?
Good.
Okay. All right. Good deal. Okay. Chase crew, how does it look as far as getting a data point or getting a video?
It's a little spotty. We're seeing blips of signal, but we're not able to keep it constant.
Okay.
Signal.
So do you have any Oh. Uh-oh. So sad. Okay, we got to refire up Google Earth. Google Earth died.
86,000.
86,000 feet. Okay. So, Christine, the Python should still be running, right? Okay. So just see if you can start the, let me see one thing here that will help you a little bit. Let's see if they're still here. Okay, so you're going to have to like rerun the KMC files. Okay, Google Earth crashed, and so we're going to have to see if we can get these things. Double click on it and see if it'll go over there. Double click. Click, click. There.
86,000.
86,000 feet. Okay, guys, can you connect us back to TeamViewer and let's see if we can see anything at all as far as your video, because I think you should be pointing up very shortly.
Well, yeah, we don't have anything right now. We're still working on the signal.
Okay. All right, so you can see we are, oh, and we need our prediction.
87,000 feet.
87,000 feet. When you go to downloads. Yes. I can't hear you, Andy.
What's the max temperature?
Temperature that the pie can handle.
I do not know that. I do not know that. A range, or let's see, do we still have our prediction over here? I believe we do. Okay, we got everything back. Okay, so we have a live KMZ of our location, and you can see that we are getting on up there. What is our altitude, Ben?
87,000 feet.
87,000 feet is our altitude, and the blue is actual. Yes.
We can see the balloon from outside the helium.
You can see it visually?
Visually.
Okay, there.
It's like a tiny speck, but you can see the light.
How is the pointing, right? I mean, you should be able to look down the gun sight.
88,000 feet.
88,000 feet. Guys, are we on TeamViewer here still?
Are you able to see the radio?
Yeah. Okay. So I see myself.
There.
Okay. There. Right. Okay. Yes, I see the radio. So you're trying to get that video back, right? Okay, Ben, watch the altitude real closely because I think at 90,000 the camera should look back up. Okay, so you can see that. What's that? Altitude?
88,000.
Okay, we're still at last reported altitude of 88,000, and what you're watching is that was a live feed from the chase crew, and they're trying to reconnect to that high bandwidth connection, right? We've got the low bandwidth connection, but they're trying to get the high bandwidth connection back so that we can get a video. And this is kind of getting a little bit intense because we're getting pretty close probably to burst, and we would like to see the burst live. Okay, we would like to see the burst live. So where are we? Okay, we would like to see the burst live. Okay, so let's see. We got some questions. Okay, everybody's saying that they're hearing us now. Sound is good. Andy's answering questions. I'm looking through your comments. David Tompkins. Is this our old David Tompkins? Hey, David, how's it going, man? Good to see you if that's our old friend David Tompkins. We still talk about how you used to drive everyone crazy running that buzzer on the Arduino.
Yeah.
No, we miss you, David. Everything is working great. Yes. Okay. Are you going to upload the video? I hope so. The stream could use a description. Yeah, it really could. It could use a description. So we will. Eagle 8. launch, chase, and recovery. Okay, let's see. Let's see if we can save it. Does that work? Does that just update? Okay, so I gave it a description. Sorry. I'll try to upload it later. I want to go to space. Me too. Sir, can you please tell how you do that communication with the probes you launch? We do it at 2.39 gigahertz, and we do it on a ham band, and we do Ethernet over ham. And that is the, what, 90,000 feet, man. Our Pi cam should have just pointed up. It should have just flipped to point up. And we really, really, really want to get that video signal back. But it is a hard problem, and the chase crew is working on it very diligently. And in the meantime, we will look at our live tracking. You can see that the chase crew has parked south of Menard. They are trying to stream, or they are trying to get the antenna on the roof of the ambulance pointed up. Precisely, this is all automated. Okay, it's all automated, but they are trying to recapture the signal. And just looking at this, if there's one thing I might be a tiny bit afraid of, is it's an omnidirectional antenna on Eagle 8, which 92,000 feet, which means it is projecting out, not down. So if you get right under it, the good thing is your path length is small, but the bad thing is you're not getting in the sweet spot of the antenna. And if there's one thing looking at this that I am afraid of, is whether perhaps they might be a little too close.
Mr. McCord.
Yes.
We were able to see it up there, and we are fairly close.
So your point,
I would say within a couple of degrees.
Okay. And what is your signal strength there? It looks like that you're looking at signal strength.
Yes, we don't have the connection right now, so give us a minute.
Okay. So you think that you're just played out as far as you're pointing precisely. The interesting thing the chase crew saw is that even though we're at, what's our altitude?
92,000.
We're at 92,000 feet. The chase crew is reporting they have a visual on the balloon that they can actually see it at 92,000 feet, which is pretty amazing. But we really, really want to get that video signal back because we're getting up there to the point of burst.
Yeah, I can almost see it.
Yeah, so we almost, they can see it visually at 92,000 feet, and they are trying to reestablish the high bandwidth connection. We still have the low bandwidth connection through the Iridium satellites. Boy, this really messes up, doesn't it? Once you get Google Earth in a goofy view, it's hard. 93,000 feet. Okay. Our predicted altitude was 106,000. Okay, guys, when it was taking off this morning, we deliberately kind of overinflated the balloon a little bit because we wanted it to come down sooner. But the challenge is that it's still going a little bit further than what we wanted. Okay, but you can see we are getting up there. We'll be at 100,000 feet pretty soon, and so we're hoping that they'll regain the video signal. Okay. Let's see, back to the questions. I'm going to sign off. Okay, Emery, goodbye. Thank you. Okay, thanks. CPU should be able to handle it if you provide an adequate heat sink. Yes, I think we should be okay. So we can see the balloon with the telescope. You know, the guys on the chase crew say that they can see it visually. They have a visual on it with the naked eye. Now, you got to remember, when this thing gets up high, it might be 30 feet across, and I guess the visual, those young men have good eyes. Okay. Okay. It's just a tiny speck, so they, okay. Thanks for being this in June class. Okay, who is that? Ms. Martinez?
That's Jaden.
Okay. Hey, Jaden, you got a shout out from your aunt.
94,000 feet.
94,000 feet. Okay, let's see. Do you guys have your camera on?
No. Yeah. No.
No, we don't.
Come on, man.
Right there. Extra.
Come on,
There's
Jaden.
Jaden.
Give a shout out to your aunt, Miss Jovita Martinez. Yeah.
There she goes.
Say something, Jaden.
Hi.
Okay, there you go. Okay. You should try this in virtual reality. Yeah, that would be a lot easier than the reality. The reality is not, I mean, it's a little bit of stress here. Is the camera on board recording so that you can, yeah, we've got two cameras. We've got a GoPro and we've got the PiCam, and the PiCam should be making an onboard copy of it. The chase crew is diligently trying to reestablish the high bandwidth connection. But hopefully, if it doesn't work, we will be able to recover it when we recover it. Okay, is there a chance that it doesn't burst? That,
96,000 feet.
boom, 96,000 feet. That would be called a floater if the balloon doesn't burst, and you don't want that, okay? How are you doing? I'm doing great, okay. Matthew Holt. Hello, oh, okay, other people are saying hello to Jaden's aunt. Okay, so... Jaden, your aunt's becoming the YouTube sensation. Okay.
The cheek right there.
Okay. What is our altitude, Ben?
Altitude is
Oh, yeah.
96,000 feet.
96,000 feet. Guys, we're at 96,000 feet, so we should get a burst pretty soon. Is someone maintaining a visual on this thing?
Good answer.
Yeah.
Man, once Google Earth gets messed up, it is hard to get it back. Okay. There we go. Okay. So we can see that the chase crew is still parked south of Menard. You're getting a live feed of the chase crew.
97,000 feet.
97,000 feet, guys. 97,000 feet. What's our temperature reading?
Temperature is 58 degrees Fahrenheit.
Okay. The temperature in the package is 58 degrees, even though outside you would expect it to be like 50 below. And so we are getting heat from that radio. Our radio is heating up. The Raspberry Pi 3 puts out some heat. The Arduino doesn't put out much heat, but that is keeping things warm. It looks like they are climbing up on top of the ambulance.
I saw Jack doing that earlier,
Yeah.
and then he almost fell off.
Okay. And they're maintaining, that's Jaden there, they're maintaining a visual on the package at, what's our altitude?
97,000.
97,000 feet. They're able to see it. They are able to see it, and they are right here in Menard. Okay. They are looking at it here. Okay. And you can see that the prediction was pretty darn accurate. The prediction that we made, the yellow is the prediction, and the blue is our actual live.
Oh. There we go.
Jack, you guys still have a visual on it? Okay. So we are getting well on up there. Okay, how are our questions going? Really enjoying this. I'm an old timer. Okay, Richard, I'm an old timer too. In all this kind of stuff. Ham radio since 1963. Computer tech since 1967. Okay, Mr. Kramer. Christine here is a ham operator as well, an extra class as a freshman in high school, and most of the space team here at El Dorado High School has their extra license. So very good. Okay. This is a person keeps asking me if I listen to jazz music, and the answer is no. I do not listen to jazz. Okay. So, do we have a data point?
97,000.
Okay. So how are our other data points? What's our downrange velocity? Downrange velocity, 25 knots. That probably is an old data point. Anything on what is our downrange? How far from the classroom? Downrange distance. Okay, the Eagle 8 is 51 miles downrange. from us, and it is at 90,000 feet.
Hey, man, we're pinging the pod from here.
You're pinging the pot. Yeah.
We can ping it. We're
Okay.
just not getting good enough video.
99,000 feet. Okay, so what we just heard from the chase crew is that they are pinging the Raspberry Pi at, what's the altitude? 99,000 feet, and they are pinging the Raspberry Pi. But at this distance, the signal strength is low enough that they can't get that.
100,000 feet.
100,000 feet. Boom.
100,000 feet. Okay. Miss Grigonis and her class. Hi, Miss Grigonis. Let's give Miss Grigonis a shout out. Yay! The engineering department has the utmost respect for the literary brilliance of the English department here. Very good job, Miss Grigonis. Okay. Is this Miss Cap super proud of the kiddos' hard work?
Where's
Hey,
Tanner?
Tanner! Where's Tanner? Come here, Tanner. Tanner, you're up, man.
It's your time.
Tanner, what's the temperature?
65 degrees.
Okay, let Tanner sit down. Tanner loves the spotlight. He loves to get in front of a crowd. You know, Tanner's like one of your extroverts, like not. Okay, sit down, buddy. How's it going? Say hello to Miss Caps. Is there anything you would like to tell her?
No, not really.
Okay. Tanner's one of our engineering students. He's like one of the first to get in here in the morning, like 6:30 rolls around. Tanner's in here working on his project. What are you working on these days, Tanner?
Oh, it's Coach Moore.
Robot.
He's working on the turtle bot. Yes. Who was that? We got
Coach Martin.
Who is that? Where's
She's
Oh, okay. Hello, Miss Martin. 7th grade science class checking in. Hey, shout out to the 7th graders.
101,000 feet.
101,000 feet. Look at this. We are going up. Okay, Miss Martin, get those 7th graders ready for this class because they're going to have a challenge to outdo this year's 9th grade. Okay, because this year's 9th grade, some of the best I've ever seen. So you've got 2 years to get them ready to take this class. What's our altitude?
101,000 feet.
101,000 feet. Jack,
It's calling.
can you guys hear we're at 101,000?
Yeah.
Okay, what's going on? Okay, there's Mr. Leighton Spink. Wave, Leighton. You're live to the world. Okay, what is going on is we are able to ping the Pi over our 2.39 gigahertz radios. And so we've got the chase crew in an ambulance here south of Menard. And then they are pointing high up to 101,000 feet. And at 2.39 gigahertz, they can see the Pi and they can ping it and get a response. But that data channel isn't strong enough to kick that video back on. So the video is running. The video is being taken.
102,000 feet.
102,000 feet. Okay, guys, we got to keep our eyes open because we're close to burst. And so then just park there in front of that because you're going to say 103, 104, and then you're going to say 92 because it's going to be coming down. Okay, so we are getting close to burst, and man, it's like right now it's where we really, really wish that we could get that video signal back, but we don't quite have the bandwidth. Is there anybody in the chase crew that's actually listening to me? Is everyone on the roof?
Jaden!
Oh, Jaden.
Hey, Jaden. Do they have any signal strength at all or just pinging?
I don't know if she heard us.
Just pinging.
Just pinging. Okay. Hey, Tanner, what else are you going to say here, man? This is your time to shine.
I don't have good answers.
Tanner doesn't have anything else to say. You know what? Tanner is a man of very few words, but when he says something, it's really important. He's like an intellectual, like really, really deep thinker. What? 103,000 feet. He's like an intellectual. It's like he's very thoughtful, and he doesn't say much, but when he says something, it's like, bam, it's something really good. I enjoy getting to know you this year, Tanner. Okay, let's meet Braden. Braden, can we meet you?
Hey.
Switch seats so they can see you.
Oh yeah, you're gonna
Braden's gonna be the invisible man.
Just like me.
Oh, the video went out.
Oh!
Braden broke the video. Okay. Okay, Braden broke the video. Okay.
Well.
All right, let's look at the questions. That is true. These freshmen are smart. Yes, these freshmen are smart. COD look. Are you sure? Am I sure what COD look? What are you asking about? Sure. Hello from India. Drax attack. Okay. Is this valid on India? What do you mean? Is this valid on India? I know.
Can you hear us?
Yeah, they should hear us. Hello, hello. Okay. Guys, I'm sorry we're frozen again. Ben, what's our altitude? What?
104,000 feet.
We are at 104,000 feet. We are going to try to get this working again. Okay. You can still hear us, right?
Oh,
Okay. Let's see.
Yes, you're
Hello, hello. All right. This is not good.
there we go.
Are we live? Are we live?
Yeah.
I think our voices.
The floating head break.
Floating head.
Have you enjoyed engineering this year?
Yes.
That was not a
Yes.
yes or no answer.
What you said?
How did you enjoy
How
it?
Oh, I thought you said did you?
I said, how did you?
I enjoyed it very well.
Okay, you're another one of the really smart ones, right? You're really, everyone's here really smart. Levi's really smart. Kelsey's really smart. Logan's really smart. Logan is the championship rodeo star.
Sorry.
Rodeo star. And then we met Mario a while ago. Is Juan over there? What?
Once a pizzazz master.
Pizzazz master.
Yeah, Juan's
got Juan?
pizzazz.
Come on, Juan.
Mama. Okay, you don't have to. Josie, you want to come and say hello?
Oh, you got fired already. You know?
Mom, be the pizzazz master.
Hey, get up, Susie.
Okay, and we're looking. What's our altitude?
104,000.
104,000 feet. Okay, we're at 104,000 feet. You can see that we ascended a little bit slower than we thought. And so, what's that? They yelled something at me. Okay,
No clue.
this is Juan. Juan is also in the engineering class of freshman. How did you like the class this year, Juan?
It's pretty good.
Pretty good. Okay.
Fun class.
All right, so you learned a lot?
Yes.
Okay. You like to use the LEDs and flash and buzz and things like that, right? Okay. Hey, Josie, come over here, man, woman, person, ma'am.
Wow, one, you're famous. Pizzazz.
Okay, this is Josie. Josie, you're in the freshman engineering class?
Yes.
Did you learn a lot this year?
Yes.
You going to be in the space program?
Yes.
All right, boom, very good. Thank you, Josie. Okay.
Good.
So we see Leighton coming back in. What's going on there, guys? You got any signal at all?
Austin is still holding visual on the package. That's as far as I know.
And Jack is distracted.
Yeah,
Jack is what?
trying to fix it.
Okay. So they're just trying to home in. It's like they can see it. They have a connection. They have a connection, but they don't have a strong enough connection to get that video signal over it. Luckily, the video signal is being saved. Okay. All right.
So you will download the video.
Yeah. Okay. So let's see. So the descent now constant. No, we haven't started descending yet. We have not started descending yet. We are waiting for burst. Okay. Benjamin, you're watching the altitude, right? Okay.
What's up, kid?
Okay, Jack, what do you think is going on?
It's when we were looking at it and looking through the gun size, it wasn't that far off. I think we just need a higher gain and stuff.
Okay, so you feel like that you've got the pointing accuracy, but because of the distance, you just need to move to a higher gain antenna. Is that right?
Yeah, because we were able to ping it at about our best ping was 8 milliseconds. Yeah. Okay. Austin thinks it burst, but
Okay.
yeah, we were able to ping it for a little bit.
We have indication visually that we might have hit the peak and burst. What is your altitude, Benjamin?
104,000 feet.
Okay, we're at 104,000 feet, and we're waiting for that next data point. Okay, we're waiting for the next data point. Okay, are you able to ping it at all at this? Well, probably if it did burst. Are you able to get a ping on it now?
No, we're not pinging it now.
Okay. Well, it could be, they think visually they might have got a visual on a burst, and so we'll have to wait and see what happens. Okay. So it'll probably be 30 seconds or so before we get another data point, hopefully. 94,000 feet. We are on the way down, ladies and gentlemen.
You saw it burst twice.
Okay, so what was the vertical ascent rate? Okay, it said that it's coming down at about 10 meters per second, and so that would be acceptable. We're probably still in very thin air, so it would not be coming down really, really fast. I mean, it would not, the parachute would not be doing a whole lot at this point.
Can we see your classroom, please?
What's the question?
Can we see your classroom?
Okay, they want to see the classroom. I think I can do that. Okay. This is what it looks like. Is that showing?
Yes.
Okay.
Instagram.
Okay.
Okay. There we go. Okay. Got to see the classroom. Any other? What's
it burst. Austin thinks he saw it burst.
It's what? What's the altitude? Okay. 83,000 feet, so we are definitely on our way down. You guys hear that? 83,000 feet, we're definitely on the way down. What's that? Okay.
A pop-up?
What's that? Okay. All right. So we're at what's our altitude?
83,000 feet.
83,000 feet and descending. Okay. All right. So you guys try to keep tracking it because it's on its way down, and you might pick up the signal again. Okay.
We had a spot of like really high signal, and then we dropped it again.
Yeah, well, it's coming down kind of fast, and so probably pointing is going to be hard. Because right when you're going from 100,000 to 80,000, you don't have much air, and so you're probably coming down pretty fast.
I seen it.
What?
45 meters per
Okay.
second.
What is the altitude?
Altitude, 71,000.
Okay. Tell me every new data point you get. Okay. 71,000 feet. And so you can see that we're kind of in the model here. In the model here, we're in this fast descent area. Okay. And so let's see.
That's good.
Hey, Austin, could you hear it pop?
Almost.
Almost. Okay. All right.
Should have got. Well, I guess should have got that king.
Okay, it is on its way down. And you're giving us every data point, right, Ben?
Yes, sir.
Okay. Okay. You're getting out of the. There you go. You're scooting out of the picture. There you go. Okay.
All right. All the fire.
Do we have a data point?
Yes, sir.
Oh. That's a long time ago. Good catch, though. Hello, hello from India, Yavraj Singh. Sorry, I can't say that. Singh.
Yeah, the last I can see.
Singh. Okay. Hello from India. Yeah. Okay. My clips. The crew should just keep an eye out for it. Yeah, they'll probably start moving again here in a minute. Okay, the chase crew will start moving again in a minute. Okay. We are getting a tad bit nervous that we are not getting another data point. For the rock block to work, our Iridium satellite network, it has to keep a clear view of the sky. And so it's kind of scary. We haven't. What?
68.
Let him say it. Say it loud, Ben.
68,000 feet.
Okay, 68,000 feet. So that's good. That's like, the good news is it's not, I don't think it's dropping like a rock from the sky. Okay, so I think probably, okay, our descent rate is 7 meters per second. And to me, guys in the chase crew, can you hear me?
Yeah, I can hear you.
Okay, the descent rate is 7 meters per second, and we're at what altitude, Ben?
68,000.
Okay, 68,000 feet, and a descent rate of 7 meters per second. That's telling me that I think probably the parachute has deployed, because if the parachute hadn't deployed, we would be coming down at like hundreds of miles per hour. So I think the parachute is deployed. We would expect a descent rate of about 5 meters per second, but you know, we're still in very, very thin air. So hopefully this thing will slow up a little bit as it gets a little lower. But we're getting data, and it seems like the chute is open. Okay, let's see. So want to become a balloon. Okay, the parachute. Yeah, everybody's. Are you pinging it? Are you pinging the pie?
No, but our radio, we should be getting it. Our radio signal's good. It's good. Like, pretty good.
Can you reload the video or something? Or
we're trying.
Okay. The guys on the chase crew are getting a signal again over our 2.39 gigahertz radios, and so they are trying to regain the video. Okay, they're trying to regain the video, but nothing yet.
52,000 feet.
52,000 feet.
Negative
Okay.
41.
Yeah, that's it depends on how often the rock block repeats, so that's probably okay. All right.
I have a couple questions.
Okay, what are the questions? Okay. Yeah, no, on the descent rate, you got to understand that that's before it's hit the air, and also understand that this is just an approximation, because built into it is the lag in the rock block reporting. So we don't have accurate time scale on this, but it's just intuitive, or kind of qualitatively, it is coming down. It is coming down as we expect. The position data you're receiving, is it through the rock block? Yes, the position is coming through the satellite modem, okay? And so even though we're not getting the 2.39 gigahertz video right now, the radios are talking. We're not getting the video, but we are getting the signals from the satellite modems, okay? Okay, Self-Explorer, good to hear that you're launching. That's good, okay? Yes, there's a parachute attached, Andy says, so that's good. Okay. Do we have any other data, Ben?
No, sir.
Okay. What's going on the chase crew?
Not a whole lot.
Okay. Are you pinging?
Yeah, it's actually decent. Yeah, it's pretty decent.
Next 70 around there.
Yeah.
Okay, so what I'm kind of curious is, when we got up there to high altitude, do you think maybe the Pi camera like froze up or something?
Yeah,
We're not able to. Oh wait, we just pinged.
1 second. We're pinging the pinging right now.
Pinging pretty fast.
Okay.
Not big enough.
You going to hit the reload there? Do we have any data, Ben?
No, sir.
Okay. We're waiting for another data point. Boom! Look at that, huh? What's our altitude, Ben?
Still 52,000 feet.
52,000 feet. The camera is back alive.
Yay.
So, do you guys think you ought to start chasing it now?
No, no, we're gonna stay right where we are for now.
Okay. Let's see. We are coming on down. Okay, you know, guys, we are not that far off from the prediction.
Wait, elevation.
42,000 feet.
Okay, 42,000 feet. Okay, 42,000 feet.
I think so happened. It's called the processor. That's why we're getting so long with teams.
Okay. Guys, Jack, what did you do with the camera on the way down? I don't remember.
It's gonna change thing. It's the same, like.
I was on the way up.
Is it going?
You're looking down, man.
So this view that we're looking at now on the camera is looking down?
No, that's looking out.
That's looking out. Okay.
Below 30, you're gonna go down.
Okay. So below 30, we should see it. So we're kind of seeing the horizon there. We're seeing the horizon. Okay. So that's that makes sense. Ben, do you have a data point for us?
No, sir, I do not.
What's the last one?
42,000 feet.
Okay, we're still at 42,000 feet.
Oh, 39,000 feet.
39,000 feet. Okay, 39,000 feet. Okay. And guys, I'll just say one of the issues with the rock block is we're giving the data from the Arduino to the rock block very regularly, but then there's latency in the rock block system, the satellite modem system, and we don't always get the data points in the same order that they were sent. And so therefore, you've got to be real careful on timing because you don't have the data you need to do really good timing. Okay, where are we? There we are. Austin and Jack, the rock block is still reporting. We're at, what's the altitude?
39,000 feet.
We're at 39,000 feet. We're down to 1.4 degrees Fahrenheit. And now why does that happen? Because now that we've got air, the air can cool the electronics off. And so even though you would, it's kind of going backwards, the temperature is dropping because the air is able to cool the things down.
That should be good. For sure. Probably
Okay. I'm not sure what is the camera showing.
You're already poor quality.
Okay, so that's looking. It's maybe you've switched down the camera, pointing down now. Okay. Hello. The what?
Temperature is now negative 7.6 degrees.
Temperature is negative 7.6 degrees Fahrenheit, and what is our altitude?
39,000 feet.
Okay, 39,000 feet. You guys that are just tuning in, we're on re-entry of the Eagle 8 spacecraft. We hit a peak of, I believe, 105,000 feet. We are now on re-entry in the 30,000s of feet. For a good portion of the space flight, we were able to maintain a live video stream from space. We are starting to move again. What is our downrange velocity? 60 miles per hour. So we are probably descending the jet stream. And so this thing is starting to move. And we are going to overshoot our projected landing zone. Okay. Now temperature will start decreasing again. Yes, temperature decreases because there's air and air can cool. So it's kind of surprising what the temperature is actually doing.
London, around London. It's gonna overshoot it.
Yeah.
Unknown. Yeah, right. We have to go back into town anyway. Yeah. It's J Nephew's restaurant.
Jack, you just announced that to the world.
Good job.
Any other personal information you would like to share? Okay. Let's see. Guys, I don't know. We are definitely overshooting our landing zone of London.
Because it's
We're already well past London. Good news is we're going to make it over, maybe that's the Llano River. We're going to make it over the Llano River and not land in it.
Well, then you go.
Maybe I spoke too soon.
I don't know if that's dry though.
Yeah.
So that might be a dry part of it.
Yeah, at least that part looks like
Yeah.
Okay, let's see. Our velocity, somebody's asking about velocity right now. It's 63 miles per hour. Have we gotten another elevation, Ben? Okay. You guys, I don't even think I would drive to London right now. I think that we're going to have to let this thing go. This thing might go to like Loyal Valley, you know.
We're going to go back to town.
Okay.
Yeah.
This thing might go to Loyal Valley.
Yeah, we'll see if we can try to get video back after that. If not, we'll just go hunt it down.
Okay. All right, so we got a little video we got quite a bit of video on the way up. I mean, we were well up there and still getting live video. So that's really good. As we started getting really up into the 90,000 feet range, we didn't get any video, but we will hopefully get some data here in a minute. But you can see that we overshot our projected landing zone. And so the guys are going to go back into Murchison, and then they might be heading towards Mason. Okay, they might be heading towards Mason because here where we thought we were going to land, we're definitely overshooting it. Okay, we had a question on velocity, 52 miles per hour. What is our downrange distance, Josie? Okay, we're 68 miles downrange, and we are 2.5 hours into this flight. Okay, guys, let's ask some more questions. This would be a great time to ask questions. Actually, we hope to not hit terminal velocity because we would like to come down nice and gently, recover the package, have nothing damaged. Okay. You guys, this would be a great time to ask some more questions because we are just waiting for this thing to come on down. What's your question?
Okay, so what happened to that one package over there?
Okay. Yeah, Logan was asking about Eagle 6, which we never recovered. And the Eagle 6, we were using the Spot Gen GPS tracker, and it did not report. I mean, it basically stopped reporting data, and therefore we lost the package and we weren't able to recover it. So we have no idea. Now, you would think it would be very visible with a big orange parachute, but it also had a GoPro and some expensive equipment on it. So we figured, okay, 22,000 feet, I'm told. It could be that somebody found it and kind of wanted to hang on to that nice GoPro camera. Okay, so you can see we're getting down there. We're not going to go to Loyal Valley. That is not going to make it to Loyal Valley. Guys,
all right, gonna take a break. Be back momentarily.
Okay, you're at 20,000 feet.
Oh, wow.
Man, it's hard to get a good chase crew these days.
Is.
Have you noticed how hard it is to get a good chase crew? It really is. Okay, what's the questions here? Okay, that velocity, that 19 ng
I think it's
travel,
supposed to say long.
that 19 long travel, they need drive back. I'm not sure any dozen what you're asking.
I think that they were trying to press O and they accidentally pressed 9.
Okay.
So it's long.
We're where, Ben? What's altitude?
21,000.
Okay, we're at 21,000 feet. They need to drive back. Well, we've got to kind of see where it's going to land. And now we're not so much trying to keep a video signal as we're going to start our recovery effort, right? Because you can see, well, probably it was dropping uniformly, and then we just get like an update here. So it's a little bit strange how the things come in. Okay, what happens if it lands on? Okay, you know, here in West Texas, we're real respectful of each other, and so we're respectful of the landowners. The landowners are usually easygoing people, and so if they see a bunch of high school students who just sent something to space, they're usually real cool with it. Okay. So in West Texas, we're not a bunch of litigious type of people. Can we see the video right after it lands? We will see what we can see. Is it true? Let's see. Benjamin McGee was one of our, from our group, was one of our first people that got his extra license when he was a freshman. Yes, so we're very proud of Benjamin. We'll get him on here in a minute. Okay, I do not think we will get an impact force that big. Okay, let's see. And guys, you can't do timing on what we're doing here because if you look at it, the thing is not updating. As we're coming across here, it's not updating. Then it updates. And so you really can't try to calculate descent rate on this. Hey, Benjamin, come and give a shout out to everyone watching here. Benjamin has been very busy watching the data. Okay, and Levi's going to continue to report. Levi says it's 19,000 feet. Why don't you let him sit here? Oh, okay.
There we go. You can see him.
Okay, Benjamin, get in the picture. Okay. this way. This way.
Other way. There you go.
There you go. Okay. Not out of the picture. You can see yourself. Okay. So Benjamin, you are a sophomore, right?
Yes, sir.
How many class periods are you in my room?
At least 3. If you count before school, 4.
4. Okay. So you spent a lot of time in here.
I do.
So have you enjoyed the engineering program?
I really have.
What project did you do this year?
I built from scratch a sorter that sorts M&Ms by color.
Okay, tell us how that works.
Basically, it funnels the M&Ms into a pipe, which then goes into kind of, I guess, a turnstile type thing, which then a stepper motor rotates it over to a color sensor. The color sensor determines which color it is, and then it asks you what color you want. If it matches the color you want, then it puts it to the left. If it does not match the color that you want, it puts it to the right, and then it sorts all the M&Ms in the funnel accordingly.
Was this one of the easier things you've done in your life?
Surprisingly, no.
All right, the chase crew is back. Okay, guys, we're at chase crew. We're at 19,000 feet. This thing is going to land probably south of Mason. We're at 16,000 feet. Okay.
So we should go to Mason? That's what you're saying, right?
I don't know. I don't know where you should go.
Oh, come on, man. Come on, man.
I mean,
man, you're going to be south of the river. So you're going to have to find a bridge. I think 1871 has a bridge across the river.
yeah.
Ask Mr. Graves if he's willing to go cross country.
Just for the river.
The river.
1871 might be where you're going to have to get across the river.
Hey man, should we just wait until it lands and then kind of know where to go? Not worry about video for now, or?
Went.
13,000 feet.
We're at 13,000 feet. I think you guys are going to have to get on 1871 and cross the river.
You're not gonna get to this. Not even try it.
You're going to have, you guys, are you listening to me?
Yeah, yeah.
You're going to have to cross the river. Okay.
Okay.
So you're going to have to get on 1871. And 1871, I think, is the other side of Mason.
Look at the corners.
1871 heads south out of Mason, I think.
So we should go to Mason.
Yeah.
Okay.
Head that way, and then when we know something else, we'll tell you. Okay. Who is that?
You're live.
Tell them they're streaming live to the world. We had some interested bystanders at the convenience store. Okay. So.
You or you? Okay.
Okay. What's our altitude?
13,000.
Okay. Oh, Ben walked off in the middle of his M&M story. The M&M sorter did work. He did a good job. Okay. And we're still working on a final few details on it, but it was working. Hi, how are you doing? Welcome. What's our altitude, Ben?
Still 13,000.
Okay, 13,000 feet. Guys, we're at 13,000 feet, so we should be on the ground pretty quickly.
Yeah, we're not even going to try to get video back. By the time we get where we need to be,
okay,
they're already on the ground.
Have we thought about using LoRa, L-O-R-A, in future missions? I do not know what L-O-R-A is, so you'll have to tell me that. Wow, class is big command center. Yes, this is our command center. Long-range telemetry. We are doing long-range telemetry using a 2.39 gigahertz Ethernet radio, and we are doing Ethernet over ham. Okay. If this balloon launched from my country, it'd already be in the ocean. Oh, okay. Yeah, well, West Texas, we got a lot of wide open spaces. I'm just asking about this video so many times because I want to see it if the Earth is really round or flat. Man, the Earth is round. The Earth is round.
Watching the video, you can see the curve.
Yeah. Okay.
This is the edge of the circle.
Wouldn't it be quicker to go south of London and then catch? Hey, we've got some people making some suggestions here. They say you could catch London south, 1871 south on London. Are you guys even looking at the map, or are you sitting and eating snacks?
They're just eating snacks.
Pizza.
Oh, they're eating pizza.
What is our altitude?
Still 13,000 feet.
Okay. Where is the chase crew?
They just back in north.
You guys, you don't want to go to Brady. Okay, we are on our way down. What's our altitude? We're at 13,000 feet. Okay. Very good. Okay. We can just, can we just using drone?
Just bring it back.
Brought it back. Okay. Yeah, we have some pretty nice drone equipment, but the problem is the laws changed and the drone stuff is just where there's all types of technical things that you can do, but you can't, the problem is legally they've just made it where you can't do anything with drones anymore in the United States. Okay. So we see top 5. Yes, the Earth is round, we agree. Okay. Austin, where are you guys? Okay, why don't you guys just pause until we see where it lands? Because somebody said there was a south way in that you might be closer to. So why don't you just pause in place till it lands, and then we'll figure out a recovery route. Yeah, just stop. Do we have a data point, Ben? Okay, we are getting antsy because we need to get data all the way down. Well, look, one interesting thing is it's kind of turned the corner. if you look, right, that last data point turned the corner, it was coming this way, and now it's gone back that way. And so it was like, I guess I would say it was heading south.
Yeah.
Jack, the package is heading north now.
It's 3,000 feet off the ground. You just got a new data point.
Okay, 3,000 feet. So we are on final approach, ladies and gentlemen. We're at 3,000 feet on final approach. Ben, do you have that data point? What does it read? Okay, 2,000 feet. We are on our way in. Okay, there you can see. Guys, you're going to be really close to 1871. Okay. You're 0.4 miles from 1871. This is going to be a snap to recover. Okay. Yeah, somebody said the Earth is a sphere. Yes, we kept saying the Earth is round. Yes, Annie, the Earth is a sphere. Thank you for the correction. Okay. Okay. We are waiting for that last data point. We are going to be on the ground almost very, very quickly. Okay. Guys, this thing is going to land on 1871.
Yeah.
This is going to be like the easiest recovery we've ever had.
That's what they always say, man.
Easy for me to say, right? Easy for me to say. Who was it that gave me the tip on 1871 coming in from the south? Okay. Whoever gave us the tip on 1871, where is Loudon? London.
Who gave us the tip, man?
I don't know.
There's
You want to go to 1871, you want to go through London and go to 1871. Okay?
All right. We're going to let it land.
I think it's, what's the altitude, Ben?
1,700 feet.
1,700 feet.
It's getting like really close to the road, so.
1,700 feet on the way in. You are going to be a very nice 0.3 miles.
Oh gosh.
Yeah.
Get to you guys go to 1871. There's no reason sitting there.
Yeah.
Jack.
So we're going to London, right?
Yeah, well, trace it out yourself, but go to London and then 1871, okay?
Okay. So go to London.
Yeah.
Okay. Okay, we're going to London. I don't think it's going to
Okay, the chase crew is on the road. Okay, let's see. We've got such a cool project for high school. Yes, Wayne, thank you. This is cool. Earth is a sphere. Yes, LoRa enables very long range. There is an open global network with access points all over the world starting to get popular, and a lot of cheap modules are available on eBay. The question is for Peter on LoRa, does it give you high bandwidth? Because our main concern is getting these videos. Ben, where are we?
We're still at 17,000. No, we're at 770 feet.
Okay, 1,700 feet. So we probably, I'm guessing, are already on the ground. Okay, I am guessing we're already on the ground. And guys, one thing that you have to realize is that this might not know where the ground is, and so it might just get here and just sit. I am thinking probably we're on the ground already.
Yeah.
Okay. Chase crew, I think we're on the ground because, you know, you don't know exactly where sea level is, and I think we are probably sitting on the ground.
Yeah, man, it's lower than we are.
Yeah.
Yeah.
You want to write this down?
Yeah. Hey,
30. I think you want to go.
Here, man.
What? Do you have the lat lawn there?
Yeah, we can see it here. We can see all of it.
Okay, good. All right, so you can see that I think it's probably on the ground there. And you are, okay, you are 0.28 miles. You're a little over a quarter mile from 1871. Okay, so the thing is that you just need to get there at this point. Okay. All right, do we have any more questions? Okay, U.S. is big, yes, and Texas is big too, and McClipsnoo, yes, boom, we are on the ground. The Eagle has landed, okay, and you guys are welcome to stay tuned. We're going to be now, you can see that we tracked the re-entry of Eagle 8 on this most fabulous mission, and now we are in the launch is over, the chase is over, and now we are on to the recovery. Okay. I guess they didn't want to go to Junction. So you guys are like going to go through Hext. Is there a place you can cut over to London like at Hext? Can you take 1221 or 1733?
1733.
Hello, Jack. Are you guys navigating?
I think they're too busy eating.
I think they are. Okay. So they could actually see it coming down. I don't know. Jack, can you hear me? Jack, calling Jack, calling Jack. Okay. I think that they could see it at the apex of the flight. They could see it when it was at 104,000 feet, which is very surprising to me, but they had a visual on it. I don't think they could see it coming down because the balloon itself was probably 30 feet across at the maximum height. Okay. What's that, Ben?
We have a vertical ascent range of 0 meters
Okay.
per second.
So 1,700 is probably ground level where they are, right? Okay, so that's probably almost certainly on the ground. Okay, they could see it. What is this nonsense? Okay, they could see it at the top of the flight because the balloon is like 30 feet across when it's all the way up there. I was surprised to hear that they could see it, but I don't think they could see it coming down because the parachute's 4 foot across, and I would just be surprised if they would actually be able to see that. So, Jack, what route are you guys taking? Okay. Hey, Jack. Jack. Earth calling Jack. Who has Jack's digits?
I do.
Okay. Call him and ask him what path they're taking because we're having trouble seeing where they're going. Are they going to find a shortcut across there? Or?
You got it, Logan?
Okay. Guys, this will be a great time to ask some questions. We're trying to get a hold of the chase crew. We see them on Skype, but they're not responding to us. And we're trying to sort of figure out what their game plan is as far as, I would try to like cut across here. Maybe not.
What?
1221 would probably do it.
Yeah.
Okay. All right. So what we're tracking now is this is where we're trying to get right here. Okay. And for those of you GPS oriented, our latitude is 30 degrees, 37.409 minutes, 99 degrees, 25 minutes, 27 seconds, okay? That's where we're trying to get to. It looks like it's really close to a road. And then that's where we're trying to get to. And then here is the chase crew up here. And let's see what kind of distance they are away.
They said they were going to go to London.
Okay, they're at 21. How are they going to get to London, though?
I don't know.
Are they? Tell him to turn his Skype on. What is this nonsense?
Call dropped.
Okay. Tell them to talk to us on Skype, that it's on, but it's like they're not talking to us. Okay, we're trying to reestablish connection to the chase crew. Hey. So what path are you guys taking to get to London? Are you going to take a shortcut across there? It looks like there's a lot of different little roads. Hello? All right. Okay, let's see if we got some more questions here. What's Eagle 8? Eagle 8 is an instrument package that our students developed that they just sent to 105,000 feet. And it has returned to Earth, and they are now trying to recover it. So this was the prediction in yellow. This was the actual flight that we just tracked in real time in blue. It has just a few minutes ago landed, and we're now tracking the chase crew in red, who's trying to get over here to do a recovery. Okay. Logan, is there a reason Jack won't talk to me on the thing? Okay. So let's see. Yes, this is Eagle 8. Yep, okay. Good project, thank you. Mr. Ballou, yes, sir. Okay, John is asking why the prediction failed, and the prediction failed because we did not quite achieve the vertical ascent rate that we were expecting, and because we ascended slower, we stayed in the wind longer, therefore it went further. And we were measuring neck lift at launch, but we did not quite get the neck lift that we were anticipating, and just a small difference keeps you in that wind a lot longer. But we're very happy with the results. So, okay, why did the prediction fail? Okay, that helps a lot. He's getting a ticket. Yeah, Jack is probably getting a ticket, but you've got to remember we've got lights and sirens, and so we, you know, we'll have to get them. Hopefully, here in a minute, they'll give you an external view. Maybe we can get them to somehow show you an external view of the ambulance. Okay. Let's see what else we have going on here. This is that kind of slow time, you know. All right, what happened to these guys? Let's try to raise them again, okay. Okay. It could be that they're in a dead zone too. Sometimes there's not good cell coverage, so that is another possibility. Calling the chase crew. Okay, it'd be a great time if you guys have some other questions. This is that kind of dead time as the chase crew tries to recover. What was the aim of the project? I think I saw. The aim of the project was to stream live video back from space, and we got up really high, and for the majority of the flight we had live video. As we exited the jet stream and we're up, getting up above 80, 90,000 feet, we lost the video signal. We did catch it a few times on the way down, so I would say that we had mission success. Show us your 3D printing setup and projects, okay? Not in a real convenient spot to show you the 3D printers. We have the Prusa 3D printer, and we have the most excellent Raise 3D, the big one, okay? And we're very pleased with those. So yeah, we're using 3D printers. What was the aim of the project? The aim of the project was to stream live video back from space. We were streaming live video for the vast majority of the flight, but we lost it as we started exiting the jet stream. What we will do next time is we will go to a higher gain antenna. Okay, we will go to a higher gain
Mr.
antenna.
Blue is helping us out with directions.
Okay. Hey, if they take 1221 just outside of Hex, proceed to London. Okay, hey, we've got Mr. Baloo on the spot. You guys? Okay. Logan.
Yes, sir.
Can you call Jack?
Yes, sir.
Okay, tell him to please reconnect with Skype that they need to turn in Hext. Okay. Mr. Baloo has given us some excellent directions. Okay, Michael Molnar, list your onboard sensors. We had an Adafruit GPS. We had the Adafruit pressure and temperature sensor. We had an Arduino, we had a Raspberry Pi, we had the Pi camera, we had a GoPro, and we had a most excellent satellite modem. We had a 2.39 gigahertz Ethernet radio, okay? And so on this, what we were really focusing on was maintaining that data stream and maintaining that high bandwidth connection. And so we didn't try to run a lot of different sensors, because once we can maintain that 2.39 gigahertz, we can put all the sensors we want, okay? What are your thoughts on the CanSat project? Not terribly familiar with it, so can't really speak too much of that. Is it possible to get a view from the Eagle 8 after they find it? Yes, there were 2 cameras on board. The Pi cam was both streaming. What? Okay, keep trying him, okay? The Pi cam was streaming and storing the video on board, so we should get that Pi cam video when it gets back. Okay, that'll be good. And then besides getting the Pi cam video, we did have a GoPro on there, so we should be getting some good GoPro video. Okay, we will have to wait for the package to get back. Yes, Andy, very good. Okay, what is the weight of the package? We came in just under 4 pounds, okay, because we want to be very precise in what we do here, and things are just much easier if you keep your payload below 4 pounds. All right, let's get some more questions here. And we are trying to tell the chase crew is almost at Hext. And the most excellent navigator, Mr. Baloo, has said that they need to turn on 1221 on, and I'm going to grab this before it disappears. They need to turn on 1221 in Hext, but we have lost communication with them. What?
They might have done that.
Oh, okay. I think they did turn. Okay. Maybe they know what they're doing. Okay. So let's see here. We can do a quick check from the landing zone. Ambulance is signed in. They are 16 miles. Okay, let's see if we can raise them again. Can you talk to him here for a second and see if you can get him that message?
Yes.
the temperature or the pressure is very useful.
Okay, just checking some data.
We might have just gotten them.
What is this nonsense?
What?
You took my chair!
Yeah.
What is this nonsense?
I've been sitting in your chair, actually.
What
we
is
might
this
have
nonsense?
gotten chase crew.
Okay. Did you guys get the instructions from Mr. Ballou as far as how to get there? He kind of gave some pretty good instructions. What?
Did he send it to JD?
Okay, let's see. What's that?
It's been on 12:21 for the last 15 minutes, man.
Okay, so from 12:21, from 12:20, oh man, where did my message go? From 12:21, proceed to London, and then you want on 377.
So go to London at 477.
Yeah, let's see. Let me see, is Austin nearby?
Yeah, Austin's right here.
Okay.
We understand what you're saying, but we're not driving.
Okay.
Okay, so we'll share it with them, but right now we have a little ways to go to London.
You have what?
A little ways to go.
Yeah. Okay. I just Austin, check your phone. I just sent you a message, and so if you would give that to the driver, it sounds like Mr. Ballou had really mapped this thing out. Okay. Okay, so what you guys can see is we're continuing to close in. You can see in red we've got the chase crew, and it looks like they are now 13 miles. Now it's not 13 miles straight, so it's going to take them a while to get over there, but we are on the track, right? We are on the track. Okay. Okay, let's see if we can get back to some questions here. This is the kind of slow thing for you guys hanging in with YouTube. Let's see what we've got. We talked about our onboard sensors. Is it possible for the crew to send a picture from the package, please? Okay, yeah, we will do that. So you guys, Austin? Austin? Hello?
Yes.
Okay. When you guys get there, Austin, if you would private message me pictures, then I can show them on the screen here. So as you're looking for it, send still pictures as you are on your way. Or if you wanted to call me on Skype from your phone, maybe you could sort of track things from there. Okay. All right, so yeah, so my clips, we will be trying to get video, or we will be trying to get updates as they get out and are walking to the package. And so we will either do that with Skype on the phone, or we will do it with still pictures, but we will be trying to do that. This isn't including the balloon or parachute. Okay, yeah. Let's see. Very interesting. So is this the idea that not quite yet. Okay, but remind me before. Oh, really? I thought it's like 11 o'clock.
Yeah, there's still a lot of time. This is only fourth period.
Oh,
Yeah. Okay.
the wrong class period. Never mind.
That's all right. You're doing good. Thank you. Appreciate you thinking about it. Okay. So let's see. Is it possible for the crew? Yeah, we'll get pictures. Very interesting. So the idea is that if the plane crashes into, well, first of all, we file a NOTAM, okay, and so we get a notice to airmen. Everything is legal, okay, but I really don't want to talk anymore about the legality of things because we're following the rules, we're filing the paperwork, we have FAA on board, all that stuff. But, you know, I don't want to be giving you advice on how to do it. Maybe laws are different in the country you're on, and so we really don't want to talk about all the different interactions with FCC, FAA, all those types of things that we have to do. Okay?
Yeah.
All right. Okay, so we are sitting here, and this would be a great time to ask questions. Okay, this would be a great time to ask questions. And you can see that our intrepid chase crew is approaching London, Texas, the booming metropolis of London, Texas. And then from London, they've got to make it over the river. Is there a bridge? I hope there's a bridge. Where's a bridge?
It's gotta be on there. Oh, there you go.
Did we put the deep water fording kit on the ambulance yet? Make note, deep water fording. How big is the Eagle? How do you power it? The Eagle runs on a battery, okay? It weighs 4 pounds. The parachute was a Kmont 1500. We were trying to get it down before it hit rough territory, so we overinflated it a little bit. It still went a little further than we wanted, but we did get a most excellent landing zone, okay? So, Niles Anti-Nergard, I just butchered your name. I'm very sorry, but hopefully that answers your question. Those of you that are just checking in, the Skype is with the chase crew. Okay, Jack, can you hear me? Does Austin have Skype on his phone?
No, I have Facebook video, and we can talk back and forth on that.
Okay, so Facebook video, all right. We have every imaginable telecommunication stuff here. Okay, so you guys, in YouTube land, this is the slow part as we are trying to do the recovery. Great time to ask some questions. Okay, on the battery, don't want to really talk about the battery. You've got to get something. You got to use a battery that's safe, and you got to use a battery that will hold the power, and you got to use a battery that is within the legal weight limit. So I don't want to talk about the battery because you want to be safe and you want to be legal, and I am not sure where you live or how this would work. Is this open source? Every single thing that we did, we developed from scratch here. All of our software is developed from scratch. We can't really share the code because it's pretty ugly code. Our code was really designed to get to mission success and not necessarily be impeccable examples of wonderful coding techniques. And therefore, it would take you a long time to figure out what we did because there's all types of IP addresses hardwired in. Certain things is very hardware specific. So we're going for mission success and not elegance of the code. So it is not open source, and you would probably never figure it out if you looked at it, okay? You know, we have been very interested. Somebody's asking if you could fly it back. We've been very interested in kind of having a smart drone, kind of an ArduPilot drone, and have it glide back. But the FAA regulations have this darn thing in it that say that you can't drop a glider. And dropping a glider, why can you not drop a glider? Actually, I think a glider would be safer than a parachute. I think a glider would be safer than a parachute. But yet, because they sort of are saying in FAA regulations not to fly down, you know, that's probably not good. Yeah, so again, we're from here not talking about batteries. Okay. Okay, Jody Jones, hello. Good to see you. Very good. It was a great day for El Dorado, I think. Very proud of these students. They have worked so hard on their pointing system, and I am just really sure that we're going to have mission success here. We are going to achieve mission success. Here is our landing zone. Our landing zone is a very, very casual quarter mile. Very easy quarter mile from 1871, and so this should be a very easy recovery. Okay. Once, let's see where the chase crew is. The chase crew is going through London, Texas right now. As they go through London, Texas and make their way to the landing zone. We will go live from the landing zone. We will try to go live from the landing zone. We will see if we can go live from the landing zone. I think this went well. What do you think?
I think it went really well.
Yeah, we were really under a lot of pressure coming up to the launch time, but I think it went very well. Okay. Oh, undergrads or college students. These are high school students, okay? These are high school students, and I think it's pretty impressive, the engineering program that they have put on here. We start the engineering program as freshmen in high school, and then the people doing the freshmen help with the launch, the people doing the actual code development and engineering and mission development are typically juniors and seniors, okay? Okay. How much time did it take for the completion? Okay, Soham Ranati, I'm sorry I butchered your name. Okay, I'm sorry. I can't pronounce your name well. But how much time did it take for the completion? The launch was about 2 hours and 45 minutes. We spent an entire year getting this ready engineering-wise, and we have spent probably 6 or 7 years building all of this infrastructure that you see here. Yes, this is El Dorado High School, okay? The finest high school in the world, I must say. Would you agree?
I would definitely agree.
Yeah. No, really, it's a great high school. We're a small high school, a couple hundred people, but I think it demonstrates that you can do things in a. Why did we die?
Go to the other one that says live.
Oh. Okay, there you go. You scared me. Okay. You know, we can do things in a small school that you can't do in a big school. You know, first of all, we have the administration that's willing to look at out-of-the-box ideas. We have a school board that is made up of not like politicians or things like that. They're like local businessmen and women and leaders in the community. And so if you've got a good idea in a small school and you've got a great administration, you've got a great school board, and you have incredible community involvement, you can do great things. And so like one of the things we were talking about is the ambulance that we're using that you can see over here Skyping into. That ambulance was donated by the Sheriff's Department to the program. And man, you want to talk about getting high school students excited when they have their own ambulance, you know, full of radios and full of equipment and all that sort of stuff. Man, it's like they want to come to school. And so you can do things in a small school that you can't do in a big school. We have great teachers. We have exceptional students. We have great administration, principal, superintendent, and then a very attentive and professional and very, very great school board, and then just incredible involvement from the community. And so great things are happening at El Dorado High School. Okay. Best of luck. Okay, we've got Mr. Wanted's got to go. Okay, congratulations on the project, Pedro Pinto. Thank you. What other projects are you mentoring? Oh man, we have so many projects. I think our student earlier mentioned his robotic M&M sorter. We've got somebody working on a system with a robot that will make a coffee and drive it somewhere. So like the idea is somewhere in the school you could order a coffee and the robot would make the coffee and drive it down to you. So there's all types of neat things. We kind of got into drones, but then the drones, it's like technically there's great things you can do with drones, but then the government got involved and passed all these laws that make the drones kind of not very interesting anymore. What are you using for position reporting? We are not using APRS. We are using a GPS that is reporting through a constellation of satellites back to us. We have 100% coverage of the Earth through a satellite modem, and that is how we are tracking our wonderful chase crew. Does it seem like they've gotten stuck in London here?
Yeah.
Jack, where are you guys? It looks like on our list it shows that you're kind of stuck in London.
No, we're just that.
You're what?
We're up to date. We're past that.
Okay. So we're just waiting on another data point. Okay.
Fixing to turn on 1871.
Okay, they're fixing to turn on 1871, so I wonder if this is 1871. Where is 1871? Ah, okay, we got some data. All right. Okay, let's see if we can see where they are. All right. So guys, in YouTube land, oh, wow.
Oh, hey.
Okay, so all of a sudden you see the rock block got behind, and then all of a sudden we got a bunch of data all at once. Okay, so they've gotten off 377, and they are on, it looks like, 342, which turned into, okay, they're on 385, which turns into 331, and they should cross the bridge shortly. So where is, all right, so you see there was not a very direct route, so they're fairly close, but they're having to kind of take a circuitous route. They're still 10 miles away. Okay, so do you kind of see the path that they're taking? They're coming down here, and then they'll circle around. Mr. Ballou says once they are on 1871, it looks to be about 10 miles to near where you just talked about the estimated landing site. Yeah.
Sounds good.
Okay. Thank you, Mr. Ballou. You really came through for us. Okay. Sounds cool. Wish I was studying with these guys. Yeah, we wish you were here. You know, tune into the most excellent TopTechBoy.com YouTube channel. If you haven't subscribed, please do, where we continue to upload more high-tech videos.
Oh, yeah. He asked me something.
Okay, I think they're to the bridge, right?
Yeah, they're getting really close.
Okay, hopefully there's a bridge there.
Yeah.
Yeah, they just made it over, man.
God.
Okay. Do you think they're going to cut across on 1871? Okay, here's what we need to see. We need them to cut across here on 1871, and then, man, it's going to be a straight shot in. Straight shot in. Next time we live stream, wear a red shirt.
Oh, yeah. I'll be more prepared.
Well, blue. You would think blue would work.
I didn't think blue, yeah.
But you've been the invisible person here. The floating head. But that's okay.
All right.
People understand green screen, so that's okay. And we are not hearing anything from the chase crew.
Hmm.
You think we lost them? All right. Okay, so Self Explorer, hi. Yeah, you guys keep asking questions on YouTube. Help us fill this time as we are waiting for them to turn on to 1871. But if you look, when they turn on 1871, it's going to be a straight shot up here.
Yeah.
And they will be a very, very simple recovery. Quarter mile is what they're going to have to do. let's see. I think if we lost connection with them, we probably won't get an update. I think the update happens from the... No, I guess we
They're
are.
on the right track.
They are indeed on the right track. So they've gotten on 1871. We'll back off here. Kind of let you see the whole thing. Red is the chase crew. This was our launch. Red is the chase crew. Yellow was the prediction, and blue was the actual. And the Eagle 8 landed after about 2 hours and 45 minutes. And now our chase crew in the ambulance is on 1871, closing in. Closing in. Hello, Soham. I'm sorry I can't pronounce your name. You are from India. Very good, very good. The shirt doesn't matter. Okay, you have an admirer. Keep it nice. Keep it nice. Okay. What projects can I recommend for undergrads like you? Like I say, take the Top Tech Boy lessons, and I have hundreds of videos with lots of project ideas. Build your skills, and then you can go off and believe you can go on and build things. I believe that would be First Presbyterian Church, El Dorado, Texas. We love our invisible Christine. Yes, very good. So you got some of your friends. You're building a fan base here, Christine. Keep it nice. Keep it nice. I will block you. I have blocked people before. Keep it nice. Okay, so we're on 1871. Okay. How did you predict the flight path? Go to HabHub, H-A-B-H-U-B. Know all of the parameters of your flight. It takes into account the weather, and you can enter those parameters. You have to do it very accurately, but if you enter your parameters accurately, you will get a very accurate prediction. We did not quite, we were going for about an 8.3, I think. Let me look and see. We were going for a neck lift today on this flight, a neck lift of 8.2 pounds. And I think we got to about 7.9. We didn't quite get the lift. It's very hard to measure because the balloon's kind of blowing around. So we didn't quite get the neck lift, and that's why it went further. Our other parameters were accurate, but I believe we probably missed on the neck lift. Okay, guys, still have 65 people tuning in. You guys stay tuned in because it'll get interesting here in a minute as they approach. Okay, let's see. Let's see if we can reconnect with them. We will, hopefully they'll have cell coverage there. If they don't have cell coverage, we will probably, okay.
That was pretty quick.
You guys are closing in. You know where to stop?
Yeah.
What's that? Okay.
We have 7 miles to go.
Okay. Let's see. Yeah, 7 miles would be a good stopping spot. Okay, how did you deploy the parachute? Okay, you know, the parachute is a really, really tricky issue, and you want the parachute to deploy properly. And what a lot of people suggest is take the top of the parachute and connect it to the balloon, and the bottom of the parachute and connect to the package. And that way, going up, the parachute is held closed. Then when the balloon pops, the balloon folds over and the parachute opens. But the thing is, if you can imagine it, that string then is wanting, because the balloon has weight, the string is wanting to collapse the parachute. So Miss Christine designed a very clever little clip that holds the parachute top to the string as long as there's tension in the string, as long as you're going up. But when it pops, it loosens, let the parachute go and open. And that's what we're going to try to get pictures, and hopefully what we're hoping is that chute deployment system that she developed allowed us to get a better, less tangled parachute. At what distance from the origin did the high altitude balloon drop? Let me look. I've got that on a data screen. 71.9 miles downrange. We landed 71 miles downrange. Yes, clever engineering job. I agree, Christine. Very good job. And like I say, over 70 miles downrange from we landed, and we got to 105,000 feet. Okay. And we'll take days to analyze this data, but I just think it's cool that we were able to track this in real time. And we're now watching the ambulance close in. We're watching the ambulance close in. We need another data point. Okay, in the next 6 or 7 minutes, while we're waiting for them to depart from the ambulance and start their overland journey to recover, this would be a great time for those of you still watching, the 69 of you still watching, to ask some questions. Okay, ask us some questions. And we'll wrap this up as soon as we show you recovery. You don't have to watch them drive all the way back, but it is kind of neat to see what's going to happen when we actually get to the recovery spot. So we are waiting on questions. Okay. What decline rate do you estimate to have with a 4-foot parachute? Oh man, it should be 4 or 5 meters per second. I don't know what we got. It's hard to do timing with this thing, but we might have come down a little faster. No, I think we probably came down at about 5 meters per second, if I'm going to guess. Okay. Okay, I am going to check something out here. Christine, if you want to stay here and keep watching, I'll be right back.
Okay.
Okay, we are with the chase crew, closing in. Do we have any? Yeah, go make a cup of coffee, Miss Leslie Foster. Yeah, we'd love to have more of these live sessions. You know, guys, next time I'll give you some advance notice. We were not intending on live streaming today because there was a lot of new engineering here, and we were not sure if this thing was going to work. And so we just kind of kept it quiet. Next time I'll give you a heads up a few days ahead so that you can tune into it, okay, and plan for it. But this time it was just like we weren't going to live stream, but things went so smoothly this morning and all the systems were working. All systems were go. All things were working perfectly. And so, man, we just decided to crank up the live stream. We are closing in, as you can see, closing in on the recovery zone. What do you think? How far do you think we are?
Oh, we got closer.
Oh, yeah.
Less than a couple miles away.
And we are probably a mile and a half. Okay. I hope Leslie Foster makes it back. I sent her for coffee. Leslie, I hope you make it back. Okay. Let's see if we can get Logan in. Come in, Logan. Tell us. Okay. So Logan, are you ready to join the space program? You're in the engineering program. Are you ready to be in the space program?
Yes, sir.
Was this pretty exciting today?
Yes, sir, it was.
Okay. Do you think many freshmen get to do this type of thing in the country?
No, sir.
No, I don't think so. So tell us your most exciting rodeo story.
Well, one exciting thing that happened is that when I was in 7th and 8th grade, I made it to nationals and polls, and we got to go to Tennessee, and there were people like from like 48 states, Canada, and Australia there.
Oh, wow.
Yes.
So you're very
That's
competitive.
Yes, sir.
She's also a very good student. Very, very good student. You see that rodeo competitiveness come out in her when she's working on things, always gets the job done. And so that's very good. As does Christine. Just Christine is an upperclassman, and Logan is a freshman, but we expect very, very big things from Logan. Did you guys stop?
We're pointing at it, man.
You're pointing at it.
We're going to try to point at it, see if we can get some video back.
Ah.
Okay.
Okay, so guys, what they're trying to do is, since they're close on the ground, they're going to see if they can reestablish that video connection, and that might be kind of interesting to see. But you can see that they parked. Let's see.
They're about right there.
They're right there. Okay. Okay, so you see, this is. Oh man, they stopped in the perfect spot.
I was about
didn't
to say they're like right across from it.
So they are right here, and then the package is right here, and so now they will go overland shortly. But what they're trying to see is they're trying to see if they can get the 2.39 gigahertz radio to connect again. Just see if that works.
Well, this is ready to go.
So proud of Logan. Yes, from your Eagle family. Give him a shout out.
Thank you.
Okay.
So much.
Yes. We are all very proud of Logan and the entire team. Okay. How much of the system do you reuse each year? Do you build the Eagle from scratch? We kind of build it from scratch, but we'll reuse components. Things like the satellite modem is expensive. We'll reuse things. Things, if we have any doubt about, we'll throw away because we don't, mission success, we don't want to use something that has any issues, but we'll reuse a lot of it. Okay, but then we always want to make sure that we're low risk, so if there's any question about a component, we'll replace it. But we do sort of build things from scratch every time. Okay, what kind of data did we collect? We collected pressure, temperature, downrange velocity, elevation, altitude, all types of different things. What's going on in the chase crew there?
We have connection with the radio, and it's not very good. We're looking at a -90 right now.
Okay, so you can see the radio, but you probably can't get video at that, right?
So.
Okay. Well, let's see. Who else do we have here? You guys ask some questions. This would be a great time to ask questions. Okay, you gonna call me on Facebook?
Right, yeah, we got a 90, not too good, but probably because of the trees. Yeah, let's do it.
Where is the video?
See that? Oh.
There we go. Let's see if that's going to work. I'm going to close Skype. Austin, I'm going to close Skype. Okay, let's see. Okay. All right, guys, we're trying to establish connection with them.
Is it on the right camera and microphone?
Guys, we're trying to establish a connection with them on the fly here. Okay. Okay, we're getting a call. How do I answer? How do I answer? Okay, don't answer it here. Let's see. Hello, hello, hello. Hello, hello, hello.
Hello.
Okay, Jack, or can you guys turn your camera on?
It's on.
Okay.
Yeah, right in the middle. Can you see us? Hello?
Yeah, we're just trying to get your.
We can't see you, but
we
we can
can't see
hear
you.
you.
So concerned.
Send us a still picture. Okay, let's see.
Another fence. Another fence.
So they're climbing a fence now. Real time. This is all microphone. Where is the audio?
Can you see everything?
No,
No, we don't.
Try restarting your browser if you're having trouble with.
Okay.
Do what?
We don't have a video is the problem, okay? Okay, so let's reload. And then right here.
And then I think you have to turn on
Okay, Austin, can you hear us?
I think with the microphone's off.
Okay.
So you need to click there.
Okay, guys, we'll get this figured out here in a second.
Try
Okay.
clicking manage and see.
Oh, okay. This is the. You don't want that. Manage.
Oh. Go to camera, go up.
Okay.
Right there.
Okay.
Do you need to change the camera?
Yeah. That's a good one, though.
Ask
Okay.
before, maybe turn off the ask before access.
Okay, guys, we're trying to connect here. Okay. So where was I over here?
Just click back at the
Close
thing.
that.
No, because you just hit that. Yeah.
Okay, guys, we're trying to connect to the chase crew. Call back. Okay, here we go here.
Then click the little camera.
Turn on the camera.
This one?
And go back to manage.
And then
Go to camera.
And then
Maybe turn off the ask. We'll see.
Okay, and now let's go back. Hello, hello, hello.
And then turn it on. And then done, I think.
This is not.
Okay, let's try it here. Let's see. Sorry guys, so we got everything, but then Facebook doesn't work. So let's try here.
This is kind of confusing, I think.
We have so many channels running.
Yeah.
Yeah, oh man.
Can you see?
Yeah.
You might want to screen it over there.
How would we do that?
We'll just make us bigger
okay, yeah.
instead of in the corner.
Yeah.
There's Jaden.
Okay. Hello? Okay. Yeah. All right, guys. Sorry, I don't know how long we were gone. Okay. No audio. Yeah, Calvin, thank you. We got the audio back, man. We got so many cameras and so many USBs going, it's hard to stay.
Thanks, Mr. Graves.
What's that? Yeah,
Thanks,
Mr. Graves. Very good. Hey, Mr. Graves says you guys get an A+.
Thanks, Mr. Graves.
Okay, very good. Thank you for the congratulations. Okay. Do you guys know where you're going? Okay, the chase crew is wandering through the wilderness.
Again.
Did we like every man for himself it again this time? Did we every man for...
That was you.
Do you all have Jaden at least with you guys?
You have
Yeah.
Coach Johnson with you guys.
Oh gosh. Let me call Jaden. Let me FaceTime her and see.
Oh, she's gonna get lost.
I thought we made it clear we weren't gonna separate this time.
Jaden, what are we gonna do about the audio?
The audio is working. Okay. You see the audio. You guys can hear now, right? You can hear? Okay.
Yeah.
Okay.
Wow, look at all this cactus.
There's a lot of cactus.
Okay. Okay.
Great for land management here.
Okay.
Failing grade for land.
Okay, they hear us now. Oh, okay.
okay.
Imagine finding JD in the middle of nowhere.
We're nearly back. Here's Jack. We're like right on it.
Okay, well, how come... We're looking for a visual.
Y'all see it?
Okay. You guys know nobody touch it, right?
500 feet.
Okay, do you guys...
Yes, we understand. Take pictures.
Okay.
I've told the crew.
Okay. So what, guys that are just tuning in, where we are here is we're within 100 feet of it. So they stopped on 1871 and they're now trying to make that last quarter mile. They're probably
300 feet.
I think it's a fake account.
Okay.
Maybe they just being locked.
How do we block? Okay. You guys, thank you for paying attention to that.
Audio.
Okay.
Is gone again.
No, guys, you're getting my audio, right? Hello? Audio good? Audio good? Wayne, are you able to hear the audio? Okay. Okay. Back again. Okay, good. We're good. You guys, thank you for paying attention. Okay. Okay, you guys just don't pay attention to that.
I would hide it.
Okay, yeah. It's right. I just hold on just a second. I need to and you guys just don't look, okay? But the reason I'm doing this, it's someone at the school doing this. And okay. How long does it take to go a quarter mile?
I am not sure.
It's been a little longer than I thought.
What did you say?
How long does it take you to go a quarter mile? Okay, so for you guys in YouTube land, they're walking out through the prickly pear. Okay, through the prickly pear, through the tassajia, through the cactus. But I just worry that they've overshot it, you know. It's like... Okay.
Yeah.
How do I block?
No, you won't be able to
I'm not sure.
too far.
Try right clicking on that
Can you?
name.
Are you? You
Right
have
user. Oh, you can report them.
What's that?
You might want to.
I'm not talking. Not talking to you.
Okay.
We're
I
taking
think
our
I said
time
another
building this
thing.
quarter
This
mile.
one?
Maybe.
Look at this, man.
Okay, that's the deleted.
Okay. Have you found it?
No.
Oh goodness.
Oh my goodness.
Are y'all all together at least?
Are you using Leighton's?
I think we should just loop around next.
Are you using?
That's not.
Are you using Leighton's finder?
Not currently. We're not with Leighton, so.
Leighton
Where did you
probably
go?
is.
Oh my goodness. How many?
We tell them, don't separate. Don't separate. Wait, who are you with?
Last year, people got
Me,
lost.
myself, and I.
Oh, it's the Austin show.
People just got misplaced.
Benjamin, you were the one that got lost.
It's like a quarter mile. That's like.
I feel like he's walked more than a quarter mile.
Man, okay.
Well, I knew where the hangar was.
It's a lot easier to walk the quarter mile from Google Earth.
Let's see, yards. Okay, that's like I admit 500 yards. Okay, that's a ways. Okay, so you guys playing at home? We are still.
I'll be right back.
Okay.
Wandering around.
Yeah. If you get to a road or a trail, you've gone too far.
Yeah,
Yes.
a dirt road.
Okay. Keep someone as a moderator. Yeah, we
Yeah.
working on that. Yeah, we banned him. Yeah, they are in the middle of a desert. That's pretty good. Okay. So they are just going through the rough terrain. It is cedar. It is prickly pear. It is tassajia. And so you could kind of walk right by it and not see it. But what's happening? What?
Did he find it?
Don't get too excited.
I feel like he got really excited.
Just trying.
Are you guys going to like do attendance?
Do you think it can?
Okay, can someone ban him? Yeah, he's banned. They're in the middle of the desert, yes. People got lost last year. Well, we lost a few, but we got them all back.
We got them back eventually.
Yeah, you know, guys, we've got so many cameras hooked up to the computer right now. We've got the Skype going, we've got the live stream going, and therefore, when you try to open Facebook in video, it doesn't work because it gets confused about which radio is going on. Okay, we have a visual.
There it is. We have a parachute about 20 feet up.
Oh, is it in a tree?
Oh no.
Oh gosh.
Parachute is.
I feel like he's running.
He is.
Okay, he's now running
He got very excited.
to the scene of the crime.
Oh, I see Leighton.
I see Leighton. Okay, there's Leighton.
Just get on his tiptoes.
There we go.
What's that?
He's reminding me not to touch it.
Yeah. Okay, so
Crossing another fence.
I don't see any fences.
I was gonna say, I didn't see a fence.
Oh, nope, I see the
Oh,
fence. There's
there
the
we
fence.
go. There's the fence.
But I mean, I don't see a fence here.
That should
Who
be
knows what
current.
approach they took, though?
True, very true.
Lying to me. Do you see it?
Let's see. You got to hold still and point at it. Okay, I don't see it. I see JD. You're pointing at JD.
I see JD.
Guys in YouTube land, I will show you. We reco-
I saw orange.
No, hold still. Okay.
Oh.
Okay, there is Eagle 8 on the ground. Okay.
There's the parachute.
Oh.
And is the parachute going to be recoverable?
Yes, it is in a tree, but recoverable.
Okay, so guys, we have gotten to Eagle 8. Eagle 8 is now, we're going to say, in the history books, and I want to congratulate everyone on a very, very fine showing. Okay, good job, excellent launch. It sounds like somebody hurt themselves there. Excellent launch, excellent chase, excellent recovery, excellent engineering. Okay, let's see. It's not dangerous for them to touch. No, it's not. Okay, congratulations. Yep. Okay, so we are going to be stopping this live stream, and you guys stay tuned in. Include your go in, and you can make the comments. This will go on my channel, so you can come back and watch it again if you want to. Okay, Paul McWhorter.
Christine Lindsay.
Okay, and Kelsey, stick your head in. Okay,
There
say
she is.
Kelsey.
Bye.
Okay.
I'm Kelsey.
Okay, we will talk to you guys later.